Object-oriented programming is bad by Brian Will. This is a talk from 2016 that occasionally he posts updates to, but this is the classic. This is like one of the best OG YouTube talks ever, sitting comfy with 1.7 million plays, every single one of which is deserved. Let's do it.
When I say that this video is probably the most important programming video you're ever going to watch, it's partly because what I'm going to tell you is distinctly a minority position among programmers. Probably 5% or under programmers will tell you that definitively object-oriented programming is just not a good idea, and in fact is going to lead you astray. Maybe you'll have another 20-30% of programmers who will hem and haw and say that it has some virtues and some weaknesses and it might be better applied to some problems than others. I'm not telling you that. I'm telling you definitively no, object-oriented programming doesn't fit any problem and you shouldn't take it seriously. This is almost certainly not what you were told in school. If you attended a programming course in the last 15 years or you read most educational materials about programming, the pervasive default assumption is just, well, object-oriented programming is the right way to go and it's just a settled matter. So I reiterate, this is probably going to be the most important video you watch about programming because it's going to tell you something you're not going to get from a vast majority of other sources. First off, I'm going to try and make clear exactly what I'm complaining about and what I'm not complaining about, and then I'm going to try and explain, well, what is object-oriented programming really, because if we don't nail that down, it's almost impossible to criticize. And then I'll try and account for, well, if object-oriented programming isn't good, why does it dominate the industry? That's kind of an important question, actually. And then I'll actually get into, well, why does object-oriented programming not work? What's bad about it? And then lastly, if I'm telling you to not program in an object-oriented style, then what do you do instead? What is the alternative? It's called procedural programming, but what does that look like exactly? So what are the problems with object-oriented programming? Well, first off, the problem is really not classes per se. That is, I think it's actually possible to program occasionally with classes in a way that's fairly benign. I don't think it's particularly beneficial, but for aesthetic reasons, it might seem more pleasing to have an explicit association between certain functions and certain data types. Doing this pervasively, though, as I'll make clear, is a really bad idea. That's where everything goes wrong, is when you try and shove every function of your code, every behavior, into an association with a data type. That leads to disaster. Secondly, I don't think the problem with object-oriented programming is about performance. I recommend you watch this talk by Mike Acton called Data-Oriented Design in C++. He makes some very interesting points and provides some insight into that world of programming, which most of us don't do. But I think he overstates his case. Fine, there's a lot of software out there that should be written with much more regard for performance, but I think there's tons of software that just really doesn't apply. You'll also hear complaints about excessive abstraction from generally the same people like Mike Acton. And again, here I think they're overstating their case. I think abstraction is actually a worthy goal. In practice, most abstractions aren't good. It takes a long, long time to develop good ones. And as I'll explain, a major problem with object-oriented programming is it does tend to produce abstractions that aren't any good. That's the real problem, not the idea of abstraction itself. Another interesting talk to watch is one by Abner Coinbray called What Programming is Never About. And the thing which he says programming is never about is code prettiness. His main point is that programmers focus too much on the surface concerns about their code rather than stuff that matters. I think that he actually simply misstates his case, or rather his thesis doesn't really follow from his arguments, which are generally valid. I think when really pressed, he would admit that elegance, simplicity, flexibility, readability, maintainability, structure, all these things you might file under code aesthetics, I think he would admit actually do matter, but I think the more accurate way to spin his point is that these surface-level virtues of code are good things and actually important.
Typing Hazard just made a really good point in YouTube chat. He likes this talk because eventually Brian does get prescriptive and suggests solutions rather than just complaining about code being bad, whereas somebody like Jonathan Blow just complains a whole bunch and says do better, but doesn't show you what better could or should look like. Jonathan Blow is everything I hate about programming influencer bros. Brian's on the other side of that, and I really hope that I'm building a community and a persona, whatever, that leans more Brian and less whatever the fuck Jonathan's doing. Yeah.
But object-oriented programming and abstraction-heavy programming in general fails to deliver them. In fact, it provides just the illusion.
Why did you say Oreos? I was already hungry. I'm gonna go grab snacks.
Actually important, but object-oriented programming and abstraction-heavy programming in general fails to deliver them. In fact, it provides just the illusion of these things. Object-oriented programming is sold on the basis that it supposedly provides these things, but particularly simplicity and elegance, it actually makes things worse. Lastly, be clear that I'm pushing procedural programming, not necessarily functional programming, which is a different thing, as I'll make clear in a moment. I happen to think that functional programming actually is the future of higher level code. I think it may actually be the default way we program at a higher level in 10 years from now or something. But there are serious efficiency problems that make functional programming not really viable in certain domains of programming. And so my message is whether your code ends up functional or imperative, that's a separate matter. Regardless, your code should be procedural rather than object-oriented. So it's a good time now to make clear exactly what are the competing paradigms of programming that we're really talking about. There are four main possibilities. Your code can first be both procedural and imperative. Procedural meaning that you have no explicit association between your data types and your functions, your behaviors. And imperative meaning that we just mutate state whenever we feel like it. We don't have any special handling of shared state, which can cause problems as it gets larger and more complex. But in procedural and imperative programming, we just cope with the problems as they arise. And you can think of this style of programming as being basically the default. It's the obvious way to get work done. So this is really how all programming was done in the early days of computers. But then starting in the 60s, as things got more complicated, people began thinking about, well, how do we solve this problem of shared state? Because it really can get out of hand. And so we got two major prescriptions on how to solve this problem. One of these prescriptions says that our code should be procedural yet functional, meaning that all or most of the functions that make up our code should be pure. They should not deal with state. And so programming in the style, we would tackle the problem of shared state by minimizing state, trying to get rid of as much of it as possible. The other prescription people came up with said that our code should be object-oriented and imperative, and the strategy here is that we simply segregate our state. We take the state that makes up the program, and instead of sharing it promiscuously, we try and divide and conquer the problem. We package it into these encapsulated
I do want to talk about the slide a bit. I like this framing a lot. I think that treating procedural and imperative as a default and then changing parts from there is a really clear model for where things start and how these things are different. I also really like the call out that procedural and functional's goal is to minimize state. I'm sure all of you have heard me rant about this all the time. I want my state on the DB, and I want the simplest pipe from there to my users. And that pipe is functional because the data exists in one place, the user exists on the other side of it, and I call a bunch of functions to generate the page or the content or whatever for that user. The functional pipe to that data store allows us to keep the state as minimal as possible. And I really like how functional programming mindset and paradigms enable that. Even if functional programming itself isn't always the answer, the mindset that it encourages is why things like serverless functions make so much sense. And functions, the ideology, are as powerful as functions, the concept in that way. Also, Shattered Elixir.
Units that we call objects, and objects contain other objects and so forth, and that's how we conquer the problem. And these two prescriptions are actually orthogonal to each other. We can do both the functional business to minimize the amount of state which our program deals with, and then whatever state is left over, we can then segregate into separate units of encapsulation. And in fact, I think this combination approach may actually be the ideal way to structure programs, at least in terms of high-level code, where we don't care so much about efficiency. As I'll explain, I think segregating state is actually a valid strategy up to a certain level of detail, a certain level of complexity. And so if we first minimize the amount of state which our code deals with, it then becomes a viable strategy to segregate the remaining state. You've noticed in my definition of object-oriented programming that I said nothing about inheritance, and that is because inheritance is simply irrelevant. No one defends it anymore. Even people who advocate for object-oriented programming will very, very commonly these days tell you to be very, very careful in using inheritance, or maybe not to use it at all. And so it's not really pertinent to an argument about whether object-oriented programming is good or bad.
This is such a banger take, and it's entirely correct. No comment. There's no reason to use inheritance. It's 2022.
For similar reasons, I didn't say anything about polymorphism in my definition, because polymorphism, really good or bad, isn't exclusive to object-oriented programming. You can have procedural code that is polymorphic, and in fact, even more polymorphic than is typically available in most object-oriented languages. So it's really not part of the discussion as far as I'm concerned. When I complain about object-oriented programming, I'm really complaining about one idea: encapsulation. Encapsulation does not work, or as I should qualify this, encapsulation does not work at a fine-grained level, which is the core of what object-oriented ideology prescribes, that we need to take the state of our programs and divide and conquer that problem by chopping it up into tiny little pieces. That is the nature of object-oriented code, and it doesn't work, it leads to madness. Before delving into why object-oriented programming doesn't work, it is important to address this mystery of, well, if object-oriented programming isn't so great, why does it now dominate the industry, and why has it done so for almost the last 20 years? I've heard it sometimes suggested that, well, this was an imposition of management. Management wants interchangeable developers so that it can have a cookie-cutter assembly line development process. Hence, business types were really enthusiastic about object-oriented programming promises, about code reusability and compartmentalization. It's a theory that sounds plausible to me, but the main sticking point is that object-oriented programming doesn't actually deliver these promises. You'd think people would have noticed sometime in the last 20 years, yet they seem not to have noticed. I'm also skeptical of the idea that management actually really inserts themselves in these technical decisions that often. I suppose one say object-oriented programming was well established, that became the trace of norm, and yeah, sure, management would push towards doing what everyone else is doing, so that they can draw from the larger talent pool. But otherwise, aside from pushing engineers to just go along with the legacy systems and build everything, I just don't think that many business managers really care that much about technical decisions.
I'm a business manager. I care about technical decisions. OOP is a bad technical decision. My stack lets people who work at a ramen shop writing Zig onboard in a week. OOP does not help here. Period. Just a lie. The Zig ramen archetype. Oh god, yeah. Mel's the best. They're one of the most talented engineers I've worked with. The grind is very real with that one. They'd never done web dev or TypeScript at all before working at Ping. And I like to think that the P3 stack helped them onboard pretty quick. And yeah, they destroy and quickly ship full stack features with no assistance needed. And I do think that our more functional focus stack allows them to move faster. And as a manager, I think it's irresponsible to not make decisions that, like, OOP is the manager decision you make if you heard about programming in university and are just going with what you learned there. But yeah, there aren't many positions I've personally been in as a manager or a hiring person where OOP tech would have made my life easier. So even at that level, I don't necessarily agree.
The larger talent pool. But otherwise, aside from pushing engineers to just go along with legacy systems and not build anything, I just don't think that many business managers really care that much about technical decisions. I'm much more inclined to think that object-oriented programming is something that programmers did for themselves, and the question is then, well, why? I think a big part of the answer simply comes down to Java. When it was first introduced in the mid-90s, Java seemed like a welcome reprieve for most programmers. Compared to the alternatives, Java seemed really simple. For example, on the PC, this is what application development looked like. You had to use the Win32 API in C, and not only did programmers have to concern themselves with memory management as you do in C, but on top of that, Win32 just doesn't feel like the C that you would learn from books. It's not what you would learn from KNR. It's not what you would learn in school. It's all this excess macro-heavy stuff on top. It was really mystifying. Even the tools you would use to write C programs on a Windows platform, the Visual Studio tools, wouldn't be the same as what you would learn in university probably, where you probably have a unit system, and that's what you learn. So it was all this platform with a quite high barrier to entry, but then also in this period it was undergoing this transition from 16 to 2, and so you can begin to see why programmers were desperately looking for some way out. The only real alternative at the time in PC programming was, what, Visual Basic? That was another effective Microsoft platform you're launching yourself into. I suppose otherwise you might use Pascal or Delphi, but that platform has its own issues. And so it shouldn't be too surprising that when Sun Microsystems came along and said, here's this free thing that everyone can use across all platforms, that got people's attention. And Java had other things going for it. It certainly seemed more accessible, just in terms of like its naming convention. For example, you look at the Java APIs, and you see things like file input, which is not cryptic at all. Yes, there are definitely issues in how abstracted APIs are, and APIs and all that nonsense. But on first glance, on the surface inspection, it certainly seems like a friendlier system. It's not like Unix, where you have stuff like IOCTL, which is you're supposed to know is input-output control, and other really horrible abbreviations. And then Win32 had the same thing. LPCTSTR stands for long pointer to a const tchar string. So even if you know what a tchar is and a long pointer is, you're stuck in this world where everything is cryptically abbreviated, and it's just this goddamn puzzle that you have to figure out at every step. Java came in and said, no, we don't necessarily have to program that way. We can write real programs that don't have to be horribly cryptic in that way. And then Java took things too far in the other direction, but that's, again, we'll get to that. Java also smartly had the C-like syntax, the curly brace syntax, so superficially at least it seemed familiar to programmers from C and C++, and it seemed like real programming. It has curly braces after all. And then the whole compilation to VM bytecode business was, again, very alluring to programmers trying to escape their platform headaches. And then Java also offered some very basic niceties like proper namespaces without header files. For Christ's sake, we still have to deal with header file. We are real programming in C and C++ at least 20 years after we should ditch them. If there was one thing I learned, I think it's worth giving Java some credit. Mainstream programming without header files. And then, of course, also very alluring, garbage collection. I know some hardcore low-level programmers out there that insist that garbage collection is never necessary, it's never a good idea. But whether or not that's the case, it's really hard to argue with the appeal. It shouldn't be surprising that the vast number of people doing business code applications wanted to stop making without memory management. Java also mainstreamed exceptions as the primary way to handle errors, and whatever problems this may have in practice, I think it definitely seems appealing, because the alternative is ugly. The alternative is what we do in C and C++ of having to have an inbound error return value, or like, saving to a global and checking the global after everything you call. It's not pretty. Golang with local return in that style probably is the better way to go, but that's not the solution Java came up with, and so it normalized this other thing that seemed better at the time. I think some people also came to like the subject-verb-object nature of method calls over straight function calls, because, well, this is just what we do in English. It's subject first, then verb, then object. I myself don't find it all that appealing. I prefer consistency, and I think the distinction between subject and object in many cases gets very, very murky, which is one of the problems with object-oriented programming, as we'll get to. But the style of syntax in Java led to the convenience of doing it since then, and looking for which is in their IDEs, it offers them for this data type. What are my options? What can I do with this thing? It seems to enable style programming to sort of browse. You don't have to hold all of the options in your head. You just have a vague notion of the way I'm going to take that thing and transform it to anything. I don't remember exactly what the method's called. I just wrote my way there using auto-completion in my IDE.
You don't gotta call me out that hard, Brian. Come on. Look, some of us need autocomplete. Don't make fun of us too badly for it.
Again, there would actually no reason you couldn't have the same style of convenience in a purely procedural language. You just have an auto-completion for, given this first argument, what functions take this type as its first argument, and it'd be
Oh, that sounds like DRPC.
effectively the same thing, really. But because of quirks of history and syntax design, this particular editing convenience has been implemented for languages like Java, but generally not straight procedural languages. And I think method auto-completion may actually largely explain why people sometimes claim that object-oriented APIs feel easier to use. It's because you can largely auto-complete your way through most of the uses. Another thing Java seems to be going forward is that back in the 90s, this was programming, and it seemed really logical to map components as we see them in a GUI window and classes in object-oriented programming. It seemed very natural correspondence. This was the most tangible version of the real-world model of object-oriented process. I'm trying to see how the part of the story, how that version of Java cross-platform with the swing APIs and the GUIs and look for level that's dictated on the so-called RAD, rapid application development, or RAP basic, except in Java you're not locked into Microsoft's platform. So the funny thing for me about Java is that I think in an alternate history, it could have had virtually all the same success, if not even more perhaps, if it weren't object-oriented at all. It could have just been straight procedural language, and would have had still a big long list of practice otherwise. We could have had all the same portability, the same garbage collection, the same exception handling, and so forth down the line, without any of the object-orientedness. Or at the very least, without forcing everything to both classes. It could have a language like Python, say, without classes, but also the straight procedural approach. It could live side by side just fine. So there still is this question, Java aside, there seems to be some appeal to object-oriented programming in itself. What is that? Well, I think very simply, if you go back to the 60s and 70s, as people were grappling with the problems of software systems getting larger and larger, people tried to identify units of code.
Everything as a widget just triggered me so hard. Oh god. Oh. God, that hit deep. Yeah, we just talked about it in chat a bit. I have nothing to say. This talk's really good. I don't know why I thought I'd have more comments, but like everything Brian says here is entirely correct. He has fantastic history, does a fair enough job of describing why people like these patterns, and then dismantles the whole thing. So, yeah.
Abstractions that are larger than individual functions in data types. It's natural to want to describe any complex system in terms of large-scale components, and if you talk about humanity, as you don't explain first in terms of microbiology, like that, you talk about very major organs like the brain and the heart and kidneys and so forth. As software gets larger and larger, it felt like these units of code we were building out of, the base materials, these data structures and functions, they became smaller and smaller relative to the whole. Sadly, though, the one general answer people could come up with of what is a unit of code abstraction bigger than a function and bigger than a data type is just simply a combination of the two, and hence objects were born. We took our functions and our data types and we associated them together.
An abstraction that is bigger than a function and a data type is a program. Mic drop. Sorry. I don't like pseudo-medium abstractions in that sense. I say as a React developer that writes React components that have logic contained within them all the time. But yeah, I think that those primitives are very good. Having data types and functions as your core primitives, and then abstracting things from there.
Into these larger units. We want to think in terms of paragraphs rather than individual sentences, and object-oriented programming seemed to have an answer for how we could do that. It's also very natural that as we build larger and larger systems and complex things, as much as possible, we want simple rote rules and guidelines. Object-oriented programming seems to present a unit of abstraction and a set of guidelines whereby we can incrementally accrete larger and larger systems. This line of thinking is what led us to patterns, and then so-called solid principles, and dependency injection, and test-driven development, and all this stuff, which has subsequently been piled on by many people who insist that this is now the one true way to do object-oriented programming. But to me, all these best practices represent band-aids. They are compensation for the fact that the original design never reached out. Every few years, there's a new ideology about how we actually do object-oriented programming for real systems.
That's not the solid y'all are thinking of. Don't get too excited.
Fine. It's very easy to miss this dynamic. I know I did for several years, because I think within all of these addendums to object-oriented programming, there's lots of mystical speech dancing around genuine insights. It's not quite cohesive. Object-oriented programming feels like this circle which we've been trying to square for over a generation. Finally, let's talk about what's really wrong with object-oriented programming, specifically encapsulation, which is the linchpin of the whole thing. So consider, what is an object? An object is this bundle of encapsulated state, and we don't interact with the state of that object directly. All interactions with that state from the outside world come in through messages. Messages to the object. The object is a defined set of messages which it will receive, called its public interface, is with private information hidden behind the public interface. When an object receives a message, it in turn sends messages to other objects, and so we can conceive of an object-oriented programming as a graph of objects all communicating with each other by sending messages. Many people today forget that the original conception of a message is not exactly synonymous with just a method call. Yes, in fact, it means called methods. But a message, strictly speaking, sends only copies of state. It doesn't send references. A message sends and returns information about state, not state itself. And, well, wait a minute, objects themselves are state, and this has some interesting consequences. It means that, strictly speaking, messages cannot pass around object references. I've never seen a Java or C# code base that will follow this rule. Perhaps some small talk programs have, but in general, this rule is not observed at all, and probably for good reason to discuss. But anyway, if we take the rule seriously, it means then, for an object to send a message to another object, the first object must hold a private reference to that other object, because otherwise, how's it going to talk to it? To talk to an object, you have to have a reference to it, and where's an object going to get a reference?
I just want to rewind to that.
Anyway, if we take the rule seriously, it means then, for an object to send a message to another object, the first object must hold a private reference to that other object, because otherwise, how's it going to talk to it? To talk to an object, you have to have a reference to it.
Nobject. There it is. Fuck, couldn't pause in time. Nobject. Nobject programming is how we're referring to object programming now.
An object going to get a reference to another object if it can't get object references from messages. The references which an object needs have to all be there at the object's inception. They have to be there for the whole lifetime of the object. And there's an even deeper consequence, which is that if an object is sending messages to another, that other object is part of the first object's private state. And by the principle of encapsulation, an object should be responsible for all the objects which it sends messages to. And this should be obvious if you consider that messages indirectly read and modify state. When B sends a message to A here, it's messing with the state of A. Indirectly, sure, but it's still messing with its state. And so what happens when other objects come along and send messages to that same object? What's happening here? We have shared state. It's hardly any different than if you had a single global variable being shared by, say, 10 functions. If you have an object receiving messages from 10 other objects, those objects are all effectively tied together because they're implicitly sharing the state.
I'll drop one of my first hot takes. I think that React makes it a little too easy to do this as well. Is the serverless? Well, not quite. The problem here is if I have like a form that's deep and a navigation bar on top, and I want to like persist some of the form but not all of the form when you change tabs. Maybe you're switching between types of a signup. You're switching between user signup and admin signup, and you want to attach the, how do I put it? You want to attach the place you're at in navigation directly to some state, but not all of it, so that some state persists, others doesn't. You're now exposing weird hooks to trigger resets arbitrarily and letting things from above hook in to a deeper component to trigger and untrigger those. It can get really messy if you don't abstract to a high enough level. And I've seen that enough times to say that declarative generally has this problem. This isn't specific to OOP. This is a declarative model problem that OOP encourages a little more heavily, but can happen in any declarative solution. Back to it.
Sure, the interactions with that state are indirect through public methods, but those methods are providing very trivial kinds of coordination of the state. You can impose rules through the accessor methods, like saying, oh, if you access this field, it's a number, well, you can only increment that number. You can't mutate it in any other way. Fine, but it's a very trivial kind of protection. The hard problems of shared state are much, much deeper. Where in the system of 10 objects all sharing the state is the real coordination? And the answer is there isn't any. As soon as you have objects being shared, encapsulation just flies out the window. So if we're taking encapsulation seriously, the only real way to structure a program is to structure our objects as a graph, not as a freeform graph, but as a strict hierarchy. At the top of our hierarchy, we have an object representing effectively the whole program. It's a God object, and that has its direct children, which represent the subcomponents, and those children in turn have their own subcomponents, and so on down the line. And each object in the hierarchy is responsible for its direct children. And the messages being passed strictly only ever go from parent to their direct child. The God object here, for example, is not supposed to reach down to its grandchild. It has to do all of its interactions with its grandchild indirectly through the grandchild's parent. Otherwise, who really is responsible for that object? Who's managing its state? It's supposed to be the direct parent. And so what happens when we have some sort of cross-cutting concern, like down in the hierarchy, it turns out, oh wait, there's some business that object has with another object in a totally different branch of the hierarchy. How do they talk to each other? Well, not directly. Everything has to go.
Does this look familiar to y'all? Y'all React devs? Yeah. This isn't just class components. This is components. Hierarchy. Hierarchy can have annoying problems. Like if there's some state in B and we want A to have access, we're either doing a stupid portal or we're doing something stupider. Yeah, context is a very object-oriented model. Good point, Parasocial. Let's get back to it.
Through their common ancestor. For A to send a message to B here, it can't actually directly invoke any kind of method. It has to mutate its own state in some way, and then information about that state, that new intention of the object, gets returned from a message sent from A's parent. A's parent in turn, same thing has to happen, so it gets back up to the common ancestor, and then only finally when we get to the common ancestor can that intent be realized as a series of message calls, but not directly down to B. It has to be bucket brigaded down through the hierarchy. That is how you handle cross-coding concerns in a strict encapsulated hierarchy. Obviously, no one writes programs this way, or at least no one writes whole programs this way, and for good reason. It's an absurd way to have to write your code. Now, you might argue that people do follow these principles in practice, they just do so inconsistently. And perhaps there is some value in a code base where you apply these principles inconsistently. Perhaps half-ass encapsulation actually gets us something. So imagine we have some sort of free-form graph of objects making up a program, and we decide, oh, well, there's a subsystem of objects that together should be their own self-contained encapsulated hierarchy of objects, and so we're going to refactor our code. Well, very often what that means is not only do we have to do a lot of complicated rethinking of the structure of the relationships here, of what calls what on the other objects, we very typically have to introduce more objects. Like say here, to represent this whole new subsystem, we probably have to introduce some new sub-god object, some ruler of this subsystem. Now all interactions with the subsystem have to be reconceptualized as going through this minor deity. So say we successfully do this refactoring, and now while our code doesn't follow the principles of encapsulation perfectly, it's doing so in a half-consistent way, and maybe there's some benefit there. Well, I think what tends to happen is subsequently we decide, oh wait, we need some new interaction between elements of this encapsulated subsystem, and instead of having to do the hard work of figuring out how exactly it all gets coordinated from the root of that subsystem, the temptation is to just handle the business directly. But if we want to do the proper thing, we have two options. And maybe it turns out that that stuff external to the subsystem actually just needs to get integrated into that subsystem, and so it comes under the purview of the subsystem's group. But otherwise, we now have two subsystems that need to coordinate. And who's going to do the coordination? Well, now we need a new subsystem god object responsible for the collective business of these two subsystems. And now all interactions of these two subsystems have to go through this root object, but also all interactions with the outside world in these two subsystems have to go through this new root object. So as you can see, tangents are really good that what you would actually do is say fuck it and just do this. You just reach in and have the objects directly interact with each other, whether they should properly do so or not. And now where's the encapsulation? What's the point? Whether you follow the rules strictly or loosely, you're in a bad place. If you follow the rules strictly, most things you do end up being very unobviously structured and very indirect, and the number of defined entities in your codebase proliferates with no end in sight. The nature of these entities tends to be very abstract and nebulous, but alternatively, if you follow the rules loosely, what are you even getting? Why are you bothering? What is the point? When I look at your object-oriented codebase, what I'm going to encounter is either this over-engineered giant tower of abstractions, or I'm going to be looking at this inconsistently architected pile of objects that are all probably tangled together like Christmas lights. You'll have all these objects giving you a warm fuzzy feeling of encapsulation, but you're not going to have any real encapsulation of any significance. What people tend to create when they design object-oriented programs are overly architected buildings where the walls have been prematurely erected before we have really figured out what the needs of the floor plan are. And so what happens is down the line, it turns out, oh wait, we need to get from this room over here to that room over there, but oh wait, we've erected barriers in between, so we end up busting a bunch of holes through all the walls, like the Kool-Aid guy, and the resulting pattern is really not organized at all, it's just Swiss cheese. We thought we were being disciplined and neatly modularizing all the state, but then the requirements changed or we just didn't anticipate certain details of the implementation, and we ended up with a mess. The lesson we should take from this is to be very careful about erecting barriers, about imposing structure. It's actually better to start out with a freeform absence of structure, rather than impose a structure that will likely turn out to not really fit our problem.
I have a really funny example of this. Did you all know that random... Step back. Sure, y'all have probably boarded an airplane before, and you boarded front to back. Did you know that random would be a much more effective way to board a plane? Back to front would be better-ish, but not significantly. Going like outside to inside from back to front would make more sense, but then you're splitting up groups and they hate that. Randomly sending people in to the plane tends to board significantly faster. Specifically because the structure gets figured out through the randomness. And that's to an extent what's being discussed here, which is when a bad structure is prescribed, that is worse than having no structure at all. Also love how many people just shouted out CGP Cray. Yes, I watched that video. Look. We're all nerds here. We all watch the same nerd shit. Y'all are YouTube degens enough to be here on a holiday. So, yeah, we watch the same things on YouTube. Sorry. Sure, more than half of you have even seen this talk, but you're sticking around because it's really good and you like me.
Bad structure that doesn't really fit our problem not only makes it harder to implement the code in the first place, it hinders change, and it confuses anyone who looks at our code because it's implying one thing, but then what's really going on is another. In the object-oriented world, we have to think about all these graphs. We have to think about an inheritance hierarchy, we have to think about a composition graph, we have to think about data flows between the object, and also we're thinking about a call graph. The liberating thing about procedural code is there's just the call graph. We also, of course, do have to think about how our data is structured and how our data gets transformed throughout the course of the program, but the beauty of procedural code is that we can think about that totally independent of any notion of responsibilities. When I'm looking at my data, I can think just about my data, and when I'm looking at my functions, I'm not thinking about all these self-imposed barriers. I'm not constantly trying to group and modularize everything into these small units of so-called single responsibilities. When I sit down to write object-oriented code, I always have to play this game. I have this mental list of the obvious data types which my code will deal with, and I have this separate mental list of all the imagined behaviors I want in my program, all the functionality I imagine it to have. And then what object-oriented ideology demands is that I take all my behaviors and I somehow associate each one with one of my data types. Inevitably, what this means in any non-trivial program is I'm actually going to have to introduce all sorts of additional data types just to be these containers for certain behaviors, which otherwise don't naturally fit with any of my obvious data types, the data types I knew I actually wanted, because they represent actual data I need. In fact, as programs get larger and larger in object-oriented code, it tends to be that these unobvious, unnatural data types tend to actually predominate. You end up with a majority of so-called data types, which really aren't there because they're representing data. They exist simply as a tax to conform to this ideology about code modularization. Very quickly, we end up in what Steve Yegi called the kingdom of nouns, where every aspect of our program has to be reconceptualized as not just mere standalone verbs, functions. They have to be reconceptualized as nouns, things that represent a set of behaviors. And so what we get in our object-oriented code bases are all these service classes and manager classes and other what I call doer classes, these very nebulous and abstract entities. Even when dealing with data types and behaviors that are relatively concrete, which have fairly visible connections to the functionality apparent to actual users of the program, even here, the matchmaking game constantly presents us with these obnoxious philosophical dilemmas. In object-oriented analysis and design, we constantly have to ask ourselves stupid questions like, should a message send itself? Because maybe instead we should have some sender object which sends messages. Or wait a minute, maybe there should be a receiver object which receives messages, or a connection object which transmits messages. So very quickly, the real-world modeling which object-oriented programming promises becomes a fool's game, where there aren't any real good answers. In my experience, object-oriented analysis and design very quickly becomes analysis paralysis. If you take the ideology seriously, as I did, you're going to waste a lot of time hemming and hawing about to conceptualize these elements of your program. Object-oriented programming is generally sold to students on the basis of these trivial examples that neatly model real-world taxonomy.
Everyone's favorite
from object-oriented analysis and design is a lot of very abstract excess structure with no obvious real-world analogs. Note here that programmers have their own peculiar definition of abstract. When programmers talk about abstraction, they're generally talking about simplified interface over complex inner workings. What's odd about this is that in more general usage, abstract has a connotation of being hard to understand. Something which is abstract has no resemblance to the things of common daily life. And it turns out that most things which programs do are abstract in this sense. And so it shouldn't be surprising that we have great difficulty conceptualizing the components of a typical program in terms of neatly self-contained modules, particularly modules which have any real-world analog. When we pollute our code with generic entities like managers and factories and services, we're not really making anything easier to understand. We're just putting a happy face on the underlying abstract business, and for every excess layer of abstraction, we're getting more abstractness. In attempting to neatly modularize and label every little fiddly bit that our program does, we're actually just making our program harder to understand.
Yep. Simpler code is always better than well-named complex code.
Something that happens all the time when I look at object-oriented code bases is that I'll try and find the parts in code that correspond to some user-visible functionality. But trying to find the functionality going by clues from the names of classes and the names of methods tends to be very misleading. Very typically, my expectation that functionality X would be in a class named X turns out to be wrong, because the abstract nature of what we typically do in programs generally necessitates that functionality is not going to be self-contained. It's not going to neatly fit into one neat module. And so the class which is called X will very superficially relate to X, but then all the real work is done elsewhere, scattered throughout the code. This makes me question, what is the value of having a class called X if it doesn't really contain all the business of X? What this class X really represents is actually misleading code structure, and how is that helpful? How is that conducive to understanding of your code base? The other reason I have this problem reading code bases and trying to track down where functionality actually lives is because object-oriented design tends to fracture functionality in our code. It tends to take what otherwise could be relatively self-contained code and split it up into many separate methods across many separate classes, typically often in many separate files, for God's sake. This fracturing is accepted because of an ideology about encapsulation and this notion of classes and methods properly having so-called single responsibilities. And there are certainly valid arguments for that idea. Certainly it is much easier to get a small short function correct than to get a large sprawling function correct. But the important question is that in splitting our code up into many little small methods and into many separate classes, are we actually decreasing the total complexity of our program, or just displacing the complexity, just merely spreading it around? In either case, there's this attendant trade-off we're making, where by splitting up larger units of code into many smaller ones, we're greatly increasing the so-called surface area of our code, where I come along and...
This is a very underrated and very good take. Like, splitting things up feels good because you chopped it and now you have a smaller piece to look at. But if you need all the pieces to understand what that piece does, you just made it more work to keep track of it all.
I look at your code base and I try and get a foothold, and everything's split up into these tiny little units, these tiny little packets of code. Reading this kind of code often feels frustrating in the same way it can be frustrating to eat a bunch of little candies that are all individually wrapped. And when all your methods are really, really short, you end up having to jump all around the code to find any line of logic. A lot of business that otherwise could be neatly sequentially expressed in longer methods gets artificially split up. So it feels like you've taken a neatly sorted deck of cards and thrown them into the air so you can play 52 card pickup. Okay, so if you're not going to be writing object-oriented code, what are you going to be doing instead? You're going to be writing procedural code, but what does that look like? Well, as I mentioned at the beginning, this doesn't necessarily mean you need to avoid classes entirely. If you have a language like Python or C++, where you have both straight functions and also classes, there are some cases where the association between your data types and certain functions is really, really strong, that it fits some organizational purposes to just explicitly associate them together by making those functions methods of that type. The most obvious example would be ADTs, abstract data types, things like queues and lists and so forth. The key thing to keep in mind, however, is that the moment you start hemming and hawing about whether this particular function really has a primary association with that data type, that should be the moment you say, screw it, we'll make it just a plain function. Because it turns out that most things we do in code tend to be cross-cutting concerns. They don't have necessarily special, obvious relationships with particular data types. They might concern more than one data type. And that's why you should generally prefer functions, so you don't have to play this silly game of matchmaking functions to data types. So we're going to be writing our code primarily out of plain functions, and we're not going to attempt to encapsulate the state of our program at a fine-grained level because it doesn't work. However, shared state is still a problem, and if we're not careful, it can get out of hand. We can't totally solve the problem unless we do pure functional programming, but short of that, there are broad guidelines we can follow to mitigate the problem. First off, when in doubt, parameterize. This means that rather than passing data to functions through global variables, you should instead make that data an explicit parameter of the function, so it has to get explicitly passed in. As much as possible, we want data access in our program to flow through the call graph. So anytime you're tempted to pass data to a function through a global because it seems more efficient or maybe just more convenient, you should give that a strong reconsideration. Secondly, whatever globals you do end up with in your program, it can be slightly helpful to group them logically into data types. Even if this means you effectively have a data type with one instance in your whole program, this little trick can often make your code seem just a little bit more organized. In a sense, you're just using data types this way to create tiny little sub namespaces. But if you do a good job logically grouping your globals this way, as a side benefit, this can complement rule number 1, because now you can more conveniently pass this global state to functions. By bundling your data together into types, you typically cut down on the number of parameters which functions have to take. Though do be careful, there is an art to how you logically group those together. The third guideline is to opportunistically favor pure functions, even if you're not explicitly working in a functional style or working in a functional language. If you see an opportunity to make a function pure, it's a generally good strategy to take that opportunity. Again, pure functions tend to come at an efficiency cost, but the brilliant thing about pure functions is that they're the only truly self-contained unit of code. When I'm reading and writing a pure function,
Oh, what a banger. Pure functions are the only truly self-contained units of code. I don't think I've ever said something that smart. That was like my own statement. God. Yeah. Pure functions are the only true unit. Everything else is an abstraction, and most of those abstractions are kind of bad and should be avoided if you can. A pure function, for those that don't know, is a function with no side effects. You call it with things, and you get back a thing. That's it. It doesn't change anything about your system. It doesn't write to a variable in memory. It doesn't modify the thing you handed it. You give it something, and you get back something else. Could even be the same thing. But no side effects, when avoidable. Pure functions, when you can. Code without side effects is not code. Nope. Fundamentally disagree. That's just a bad take. Does most code need side effects? Yes. But if you can manage those side effects, then and abstract them as much as possible, and your code is simple, pure pieces that you architect in a way that gives you an output that is a side effect. Like, running pure code has side effects in the sense that something new is created, but no. I fundamentally disagree.
I don't have to think about anything else. I can just consider that function entirely unto itself. Therefore, they tend to be easier to understand and to make correct. The fourth guideline is that we actually should try to encapsulate our code, only in a very loose general sense, at the level of namespaces, packages, modules, whatever your language has. So when I'm working in Golang, for example, I think of each package as having its own private state and then a public interface. I find that encapsulation at this coarse-grained level tends to work because you're typically dealing with much larger units of code than the supposedly ideal classes of object-oriented programming. The typical Golang program is going to have not that many packages, maybe like 10 at the high end, and structuring a mere handful of elements into hierarchical encapsulation is reasonably doable. When it turns out during development that, oh wait, I have some cross-cutting concern in my packages, and so we need to violate this perfect hierarchy of encapsulation, again, it's not such a big deal because you're dealing with a relatively small graph of objects. All the basic problems of encapsulation are still there, it's just at the coarse-grained macro level, the problems are reasonably manageable. The last guideline is that you shouldn't be scared of long functions. For a long time now, programming students have been advised to when in doubt chop their code into smaller and smaller functions, but doing this has significant costs. There are trade-offs. It turns out that most programs have these key sections where most of what the code is doing is a long laundry list of stuff. And what we're told to do in these scenarios is write functions like this, where all the business has been extracted out to separate functions. The problem with doing this pervasively is that what was naturally a logical sequence of code and was otherwise written in sequence, top to bottom, is now spread and out of order throughout your codebase. Obviously, in cases where the business extracted to a separate function is something that you want to call in multiple places, that's a very good reason to have a function. But if all these functions are just called in this one place, I would generally prefer looking at code where the business of those functions is just done in line. And if you want high-level documentation of what's going on in my func here, then you just call a section comment denoting what each section of the code does. In this arrangement, the sequence of the business is totally...
I'm guilty of this. I've been trying to get better about it, actually, writing functions that are much more top to bottom. Here's everything, not abstracting just because I can. This is a very good thing to key in on. A function that does everything it needs. Like if something will never be reused, it probably doesn't need to be abstracted. I agree this applies to React components to an extent. For use effecty type stuff, I like to break that out for the naming sake. Like if the output is a single thing you care about, I still like doing that abstraction. But that's more for clarity while reading because of the interop between React and state management solutions and use effect and JSX. But yeah, I almost always agree with this very specifically. Good shit. Anyways.
Totally clear, and when I'm browsing the whole code base, when I'm looking outside this function, there's less clutter because there are now fewer functions I have to look at and wonder, well, hey, where is that called? I wonder what that thing does. It also has the advantage of letting us avoid having to name functions. Naming stuff is really important in code, but it's really, really hard to do well, and in general, I find preferable if we can avoid naming entities as much as possible. In this arrangement, we don't have to think hard about what to call these functions. We can just have a comment line and have a full English sentence, which generally is better at conveying accurate meaning and also is simply easier to write. If, for whatever reason, it doesn't seem adequate to simply comment a section rather than extract it to a separate function, the next best thing is to make it a private function, a nested function, such that it's clear this function is not called anywhere else, it's only called within this function. In this arrangement, I, as a reader of your code coming from the outside, am still presented with a smaller surface area, fewer entities in the code, so it's just easier for me to get a foot. Now, when you do write functions which are hundreds, if not thousands of lines long, you still should keep in mind general guidelines about code readability, basic things like not straying too far from the left margin for too far or for too long. You don't want to have code that's indented in 8 levels because it gets really obnoxious scrolling down code if you have to scroll over for one thing. And also it tends to just imply there's a lot of busy logic in this part of code and it gets confusing. So likewise, you also need to look out for parts of functions where the logic's just getting too complex. The first thing to do is, of course, to try and simplify your logic, but failing that, there are going to be cases where, hey, we should just split this off into separate functions, so it's more neatly self-contained complexity. The other concern with longer functions is that as your function gets longer and longer, you tend to accrue more and more local variables. So what you want to do is, hopefully your language allows this, you want to try and constrain the scope of the local variables so that they don't exist for the full duration of the function, but rather for subsections. This way, I, the reader of your code, when I scan up and down the function, I don't have to think about all the variables for the whole duration of the function.
I write functions all the time like that, just to contain a variable so it doesn't leak from the local scope. Not the best practice in defining functions all over the place, but I do it a lot.
The way this is done in most curly brace languages is you can just introduce a new subscope with curly braces. So here, for example, this integer x variable only exists within these curly braces. When you have subsections of a function which you are commenting, it's generally a good idea to, when in doubt, enclose them in curly braces. This gives readers of the function an assurance that variables from the preceding sections don't fall through to the following sections. And so in later sections, we don't have to think about the variables that were used above. Where possible, the even better thing to do is to enclose these local scopes in their own anonymous function that's then just immediately called. And the advantage here with
Yeah, this is the thing I was saying. I do this too much. It'd be cool to have blocks this way, but
the nested function,
programming's hard.
Its own subscope, but also within this anonymous function, it's guaranteed that any return is not going to return out of the enclosing function. It'll return just out of this enclosed function. And so we have a stronger guarantee that the logic of this subsection is self-contained from the enclosing function. Unfortunately, what I often really want when creating subsections of longer functions is a feature that doesn't exist in any language I know of. It's an idea I've only seen in one other place. It was Jonathan Blow in his talks about his programming language he's making. And the idea is that we want something like an anonymous function which doesn't see anything of its enclosing scope. The virtue of extracting a section of code out to a truly separate function is that everything that comes into the function has to be explicitly passed to a parameter. It would be great if we could write inline anonymous functions with the same virtue. Specifically, what I would propose is imagine we had a reserved word use that introduces a block, and in the header of the use, we list variables from the enclosing scope which we want to be accessible in this block, but otherwise anything from the enclosing scope would not be visible. These listed variables, however, would really actually be copies of those variables. So if you assign to x or y here in this scope, you're assigning to x and y the local variables of this use block, not to x and y of the enclosing scope, which is the effect you get with a truly separate function, right? You assign to the parameters of the function, you're not modifying what was passed to the function, you're just modifying those local variables. That's the same thing we want in this use block. Furthermore, a use block should itself return values. So you use return inside the use block, and it doesn't return from the enclosing function, it returns from the use itself. The use is an expression, and so we can return values from this use and assign it to this variable a. So in effect, we have this block of code, which is as neatly self-contained as a separate function. However, it is written in line, and so it's very, very clear that, oh, this is a piece of code that's only used in this one place. You don't have to go look for it elsewhere, and also we don't even have to give it a name. Instead, we can just put a section comment header before the use block, and that is generally much better for containing the actual intent of this block of code. If later
I really like this pattern. I wish this was more popular in more languages.
down the line, we decide that this block of code actually should be extracted to its own proper function, that's a very easy thing to do. You can have an editor convenience that does that for you automatically. It's already clear what the parameters and the arguments should be. All the programmer would have to do is provide a name for the new function. So anyway, it'd be nice if languages had this feature. Unfortunately, I don't know of anyone that does. But regardless, you shouldn't be so scared of long functions. They actually have their place in most code bases. At the very least, I hope I can get you to try procedural programming. It doesn't really matter what language you're in. If you're in Java or C#, you can write procedural code, you can break rules. But if you've ever felt any of the paralysis that I felt attempting to do object-oriented programming properly, to square the circle, I think you'll find abandoning all those ideas and just reverting to procedural code to be a liberating experience. I can tell you from personal experience of having read these books that you don't need to read them. They don't have answers, they're not going to square the circle, and you're going to waste productive years of your life trying to live up to their ideals. I'm not saying
bangers.
these ideas. There are bits and pieces that have value. Test-driven development, for example, has some interesting ideas. There's value in testing. But that's part of the problem, is that kernels of good ideas have been taken to holistic extremes in a way that I think has been disastrous for the industry, and certainly for programming education. There are very few solid holistic answers about how we should write code. We'd all be better off if we stopped chasing
Uncle Bob catching strays. Yeah, that was 44 minutes and 35 seconds of straight bangers. Every point was great. Fantastic video. Every time I watch it, I am happy that I do what I do and that I know the things that I know. He's fantastic. And he has a few other videos. His Unity overview stuff's actually really good, even though I hate Unity. What's funny is he hates OOP and he's a game dev. Take that as you will. He has... where's the one I'm thinking of? He did a video where he rewrote a program. Sorry, the object-oriented programming is good. This one's shorter, really good. He goes a little more in detail on like one or two specific use cases where it's okay. But he has another where it was like he rewrote the same program multiple times. I think it's this one. Object-oriented programming is embarrassing. 4 short examples, yeah. This one is phenomenal. If you want to see like the extent at which OOP is bad, he goes very in-depth on like specific examples there. Great video. Highly, highly recommend checking that out. And generally, for game devs, check out his stuff more. He does things very different and is still very productive. Did you know that over half my viewers haven't subscribed yet? That's insane. Y'all just click these videos and give me a shout and hope that the algorithm's going to show you the next one. Make sure you hit that subscribe button and hit the bell next to it. Also, if you didn't know this, almost all of my content is live streamed on Twitch while I'm making it. Everything on the YouTube is cuts, clips, whatever from my Twitch show. So if you're not already watching, make sure you go to twitch.tv/Theo, where I'm live every Wednesday around 2 or 3 p.m. And I go live on Fridays pretty often as well. Thank you again for watching this video. Really excited. Thank you.
What is the biggest lie about programming? This tweet got thousands of likes, hundreds of responses, and there are so many good takes and so many terrible takes. So let's go over some of the biggest lies in programming. You must learn how to swap 2 variables without a 3rd variable. I mean, yeah, this is a good little piece of knowledge to have, and I've actually used it before in real programming, but the reality is no, you don't need to know that. So okay, check mark. Follow my path and you'll get to the same destination. Depends on the destination. This is one of those relative statements that is kind of asinine in the sense that, yes, if the path is work your ass off, really try hard, really deep dive, yes, you will get to a destination that is similar or actually the same destination as the person telling you. But of course, it just is wholly on what they're saying to do. And yes, there's always luck involved, okay? Yes, if someone says, hey, I'm a VP of engineering, you can do all the things Mr. VP of engineering did, but that does not mean you will now become VP of engineering. We need gatekeepers. Said nobody ever. Okay, little side note here. Let's side note this one. First off, gatekeepers, there is no one actually keeping the gates, okay? Second off, there are people that are gonna just say mean things to you. If you let that affect you and be like, oh, I can't actually do it because this guy on the internet told me in a tweet that I can't do it. Come on, you gotta get a little bit stronger than that. People are gonna say mean stuff about you all the time. This is just what life is about. But here's the deal, that you can take those mean things said and you can actually use it as encouragement to yourself. Because you know what, I think I am good enough. Therefore, I am going to try hard enough and I am going to hurdle over all these insults and I am going to be better than that. That means you can be motivated just to spite somebody. That's disgusting. But it is really good to be motivated to believe in yourself. I believe in myself so bad that I often maybe overcommit a little bit to things. I don't actually have the skills, but I learned the skills, and I know I can do it with enough time. Clean code is just for people that write books and blogs. It's and is a matter of taste without technical reasons. Again, this is actually a matter of taste statement. Okay, what makes code clean? For me personally, the things that I focus on is it testable? If the code is testable, for me, I don't really care much about it. If the function does too many things, yeah, you gotta break it up. Okay, I wanna see things broken up. Oh, but if you used this method versus that method, if you did this versus that, I honestly don't care. Switch statements, if statements, whatever. Okay, while loop, for loop. If there's a good reason to use it, I don't really care. What I care is that you can test it, hand me a piece of code that is not going to break, and if it does break, I have a good understanding of what were the expectations via some sort of unit test. There you go. Clean code for me. I know some people are gonna get really, did that rub you the wrong way? Did that rub you a little wrong? Okay, are you taping a little bit? You need a little coconut oil? Oh, that hurts me. Okay, I really love my beautiful if statements and I only use functions because classes are the devil. Okay, I hear you. Slow it down there. It shouldn't take me too long to fix this bug. Okay, this is actually personal. Okay, I just wanted you to know that this is too personal. You obviously have been watching my Twitch stream, and this is emotionally painful. Okay, actually, not funny. That it guarantees you a high-paying job. Nope! What it guarantees is your location and who you know. Okay, so first off, it does not guarantee your location. I think that just might be a grammatical error when reading this. I think what he's trying to say is that your location guarantees whether or not you're getting a high-paying job. That's actually pretty debatable. You can get a 6-figure job in San Francisco and be living below the poverty line, okay? San Francisco is a horrible place, yet it pays 6-figure jobs, okay? So, no, a high-paying job is really relative to your market. If you live in a place that $1,200 per month is considered good income, you potentially could get $2,000 per month doing programming, and that's great. That's a high-paying job relatively. Now, is that as high as, say, what you'd be in San Francisco? No, but the cost of living in San Francisco is absurd. So that is like, it's such a relative type of, you know, I just hate these type of tweets, right? Where it's just like, no, that's not how life works. And this whole who you know business, here's the deal. All a high-paying job We all don't know each other, okay? Not every last person in any one of these FANG companies are like, oh yeah, Ted from marketing, yeah, he got me the job here as senior program. No, it just doesn't work that way. The reality is that it doesn't matter who you know. That's what makes tech so dang awesome. It doesn't matter whether you live in BFE, Montana, or the Silicon Valley. You can still get a job. And like, that is amazing. And I feel like this whole thing is just missing the point. Now, this is not true for every country, I get that. But in the United States, it is very, very true that you have a massive opportunity with programming. It's my project, I did it myself. Show me your project source, I'm gonna copy it. It's our project, we did it together. Smiley, 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 smiley. I don't even get this joke, okay? I don't get this. I feel left out of this joke because what does it even mean? I don't know. We have passion in programming bullshit. Everyone is picking up programming nowadays just for the money and nothing else. This one is actually one of my bigger pet peeves. I do think you can pick up programming for the money, but to be great at programming, you really do have to be passionate. And there's like this whole missing thing that's happening, which is if you want a good job, you really do have to be good. And you know what? The thing is, if you're motivated purely by money, when you land a job that is statistically better in pay than all of your other jobs, is your motivation going to wane to learn continuously get better? Yes, it is. Will I mispronounce continuously? Yes, I will. Will you not be as good as a person that is passionate just for the sake of being passionate? Yes, you won't be as good. And so this is one of those tweets that I think is really destructive. You should have passion. You should want to be the best developer. Not because you're trying to crush other people, but because you yourself should be motivated about yourself. Biggest lie, JavaScript is a career. Edwin Torres. Edwin Torres! Thank you, Edwin! Oh my goodness, this man's a champion. All is about copy and paste. You don't even need to know everything about a programming language. This one actually is a pretty astute observation, which I think kind of describes this level, right? You'll see a lot of these kind of new tech influencers coming out where they don't have a lot of years of experience, and they all laugh about how it's just copying and pasting. You don't need to learn these things. You just got to look it up. Just use Google Copilot or Microsoft Copilot, whatever, right? We get the idea that, yes, there are some things you just simply have to look up to know, right? Do you remember how to see if a checkbox is checked in HTML? Probably just need to look that up. Not a big deal. But the reality is that the more you know about a language, the more proficient you're going to be. Okay, you're going to be able to tackle a huge swath of problems without having to look up a single thing and be limited by this constant Googling, constant trying to, frame your problem in some sort of sense. And so, I really think this is a great observation. You should really try to learn the language that you use. You should really try not just simply looking up every single answer. Take a little bit of time to try to see if you can remember the solution. Try to build it. Try to do something with it, because honestly, it is one of those tragic things that I see where people just don't even know the basics of the language. That standards are always kept by everyone involved with the project. That's not funny. This is not funny, okay? this hurts. Okay, both as a man who's worked in projects with no standards and as a man that does not have very good standards and have polluted other projects. Okay, this is painful, okay? It's a two-way street, and I'm getting cut on both sides. The biggest lie on programming is that your level of technical skill is important. False! Creativity and communication limit you more than anything else. Again, this is a very, very unique take. I would say communication is a very important aspect. Creativity, a very important aspect. But technical skill is very, very important. The fact that it just says is important across the board and then effectively claiming that it's false is just absolutely hands down wrong. Being technically competent is extremely valuable. The highest paid engineers are not paid based off their ability to be, communicative, okay? If that's even a word. Really, some of the best paid engineers is because they have an extreme technical expertise in some arcane area that is exceptionally hard to hire for. That is the reality. The mid-paying to above mid-payings are based on more this communication type barrier. The creativity one's kind of interesting. I'm not really sure how to put that where, because to be able to be technically proficient, it does require some level of creativity. To be good at communication, it does require some level of creativity. So I don't know if that really can be disjointed, as Sam over here is suggesting. Okay, I don't know about that, Samuel. Programming is easy. You gotta be very smart to program. Programming is hard. You need to be smart. It's easy. It's easy. Code is hard. You can learn stuff by a YouTube tutorial. Biggest lie of them all. All right, so is it easy or is it hard? Which one is it? It seems like everyone has a different opinion here. Now, I'm gonna try to clear this up right here, right now. Yes, programming is easy. Yes, programming is hard. It is hard to learn. Learning both syntax and semantics at the same time makes a task very difficult, okay? You don't often do this in your life. You did it when you were a baby. And guess what? You haven't done it in a long time. This is not easy. But once you understand how the basis of programming works, learning more becomes easier. But is programming easy? Well, in the fundamentals, yes, it is easy. A if statement is easy. A while loop, easy. For loop, easy. But putting all the things together in a complex project is actually hard. Good example. Do you understand how to do AND, ORs, and XORs with bits? Yeah, not too hard. You could learn all of that stuff in just like an hour. But is it hard? No, it's really not hard. But is it hard making HTTP too? Yes, that is a long, hard project to get perfectly correct and fulfill the entire spec. So it's one of those things where it's like, what do you mean? Yes, there are easy parts. Programming itself, once you understand it, is actually quite simple. Building complex projects, is that easy? No, of course not. No one has ever said complex projects are easy. This is just ridiculous. The devil's in the details, and implementation details are your entire life. Okay, so yeah, not easy and easy at the same time. Python is easiest, Python is easy, Python is good for beginners. Well, this one, the Python is good for beginners, this is actually really sound advice, okay? The fact that they're trying to display this as a lie is absurd. Python is great for beginners. It is fairly simple to learn out of all programming languages. Python is one of the easier languages to program in. It is a nice programming language to use. You don't have to think nearly as hard as you do like C++, or if you're managing your own memory. Have you used Rust? Damn it. Rust is just so not easy compared to Python. Python is easiest. Yeah, there might be a language easier than Python. I just don't know if that's actually true. Okay, Python is one of the easiest languages to learn. Now, to be obviously awesome at Python, years of experience. It takes some time. But this is just, I don't even understand how these exist, right? Yeah, Python is good for beginners. Please don't look at this as a lie. If you are learning how to program, choose JavaScript or Python. Make your life easy. I personally think JavaScript is the best language to learn as a beginner. Now, before you hate me, hear me out on this one, okay? Hear me out on this one. In fact, you need to hear me on the green screen, okay? We're going back to the green screen. Hey, why is JavaScript the best one to learn? The reason why I think it's the best one to learn is that you get an opportunity to do the front end and an opportunity to do the back end. And by doing those two things together, you can determine what do you actually like. And then once you know what you like, guess what? Stop using JavaScript if it's the back end. Okay, go use Go or anything else. But if it's the front end, hey, you pretty much are limited to JavaScript. You can kind of WAS them, but you still have to interact with JavaScript. Great language to learn. Get awesome at it. Run wild. But please, if you're in the back end, stop using JavaScript. Okay? It's not good for anybody else here. Stop it! So this last part, I think, is an excellent one to kind of stop on. That you have to have a formal education to be legitimate. You need a degree to understand it. That employment is accessible to people without CS degrees these days. Now, I think obviously this third one is kind of standing in contention to the first two, but this is all very interesting takes. Do you need a college education to get a degree? Absolutely. You do not need a college education to get it. Can we rewind that? You don't need a college education to get a job, but it is certainly easier to get a job with a college education. These people that just have these takes where you're like, you don't need it, don't do it, you're gonna go into debt and it's horrible. These people are just so disconnected, okay? It just doesn't, it's not that simple. Do I think you need it? No. Some of the best programmers I've ever met were not educated, but some of the best programmers I've also met were educated. Some fields are way harder to get into without a really formal, rigorous education. Compiler design, you think you're just gonna walk on because you read some books? No, it is really hard to break into those type of jobs without extensive education. I'm just saying you can learn, you can use ML, but to program new algorithms to really extend the base frameworks requires differential calculus, differential equations. It requires, you need partial derivatives for backprop errors, right? Like there is like a lot to it that's really hard to learn on your own and to actually show that you are good at it. So it's like one of these things that it's just such a frustrating talk on Twitter where people just have these really extreme views on everything where it's just like, you absolutely don't, you absolutely do. No, it helps to have it. It will make your life a lot easier, but is it purely able to be the only thing that makes you successful? No, you can totally do this self-taught. People at Netflix are self-taught. I've met them, I've worked next to them, I've sat next to them. It does happen. By the way, Emma right here, great point. You don't need it, but man, does it help, right? Backing me up here. This anti-cloud guy, once again, this is like the gatekeeper in the other direction, right? If that's what you believe, says the guy who maintains 11 corporate clients without a degree. Like, it doesn't matter your credentials. Your credentials do not mean that that's what everyone should do, right? Just because you didn't get a degree and you have some level of success in your life doesn't mean the person does or does not need a degree because you got successful. There's always luck in every success story. Just how it went. So if you disagree with anything I said, lay it down on me. Hit me with some comments, okay? I want to hear your opinion on some of these takes because, you know what, these are my hot takes, and I had them quite hot this morning. But you might have different takes, so let me hear them. 3 billion devices run Java. Come on, man! It's the first right once run anywhere piece of code! You know that this made some people salty. You know for a fact that some people got really salty about it. Oh, by the way, gotta translate the tweet. Nice.
This is such a bang.
Hey. I have this problem, okay? Okay, I have several problems, but my primary problem today is that I hate using cheat sheet. Not because cheat sheet's bad, but because I just have a sucky workflow. Like when I want to do it, you know what I do? I open up a new terminal, I go in here and I curl cheat sheet, and then I have to leave the terminal, then jump back, or I create a new tmux window and then I jump in here, and then that's where I do my little curl and do that, and then it shows up, okay? And then I have to jump back. I gotta go back to 1 this time, and then I have this window that's just hanging out there. I don't want that window hanging out there. That sucks. No, I don't want that. So we're gonna fix that, okay? Me and you together. Let's fix it because you know what? I want the greatest developer workflow that has ever existed. Okay, I want everything at the touch of these sweet little fingies. Why am I closing my eyes and doing spirit fingers? Well, guess what? You don't need to know the answer to that, but you will want to know the answer to this little cheat sheet gimmick. So let's do it. Let's jump in and let's make something way more incredible together. All right, so the first thing I'm gonna do is I'm gonna create a little thing called cheat sheet. Oh, looks like I already have it. What? Maybe this isn't the first time I'm recording that. I ran out of air there. I actually ran out of air. All right, so what is cheat sheet? For those that don't know, you can simply go like this, cheat sheet, and then you can provide, say, a language, and then after that, you can provide some sort of query string with the plus instead of spaces, right? Or you can do the exact same thing, but instead of using a language, you can do a core util, and then you can, people hate utils too, I love them. And then you can also do an operation if you really want, and then you can forget that part and do that, bam. So a good example of this thing would be, okay, let's just paste a couple extra of those, and let's go golang slice. All right, let's take this, let's actually, here, let's just try, hey, let's just try it out. Oh, I don't even believe you could do that. Look at this, okay? Look at that. That's how you do them. Slices. Okay, it tells you all about slices. Then you can even do more than that. You can also do learn, which is, obviously that was a terrible thing I just did there. You know what I just discovered with doing this learn stuff? It hurt.
With this kind of set of constraints, you were thinking of the world in this way. If something breaks, that means you got to rethink the initial stuff, and it's nice for it to do that. Is there any stuff like keyboard or monitors?
Yeah, I'm fairly pedestrian on a lot of that, where I did move to triple monitors like in the last several years ago. I had been dual monitor for a very long time, and it was one of those things where probably years later than I should have, I'm just like, well, the video cards now generally have 3 output ports. I should just put the 3rd monitor up there. That's been a pure win. I've been very happy with that.
Yeah.
But no, I don't have fancy keyboard or mouse or anything really.
The key things is an IDE that has helpful debuggers, has helpful tools, so it's not the Emacs Vim route, and then Diet Coke.
Yeah. So I did spend, I spent one of my week-long retreats where I'm like, okay, I'm going to make myself use, it was actually Classic VI, which I know people will say you should never have done that. You should have just used Vim directly. But, I gave it the good try. It's like, okay, I'm being in kind of classic Unix developer mode here. And I worked for a week on it. I used Anki to like teach myself the different little key combinations for things like that. And in the end, it was just like, all right, this was kind of like my Civil War reenactment phase. It's like I'm going out there doing it like they used to in the old days. And it was kind of fun in that regard.
So many people right now.
But
they're screaming as they're listening to this.
Again, the out is that this was not modern Vim, but still, yes, I was very happy to get back to my Visual Studio at the end.
Yeah, I struggle with this a lot because I use a Kinesis keyboard and I use Emacs primarily. And I feel like I can, exactly as you said, I can understand the code, I can navigate the code. There's a lot of stuff you can build within Emacs, using Lisp. You can customize a lot of things for yourself to help you introspect the code, like to help you understand the code and visualize different aspects of the code. You can even run debuggers, but it's work. And the world moves past you, and the better and better IDEs are constantly being built. And that puts a kind of, I need to take the same kind of retreat as you're talking about, but now I'm still fighting Civil War. I need to kind of move into the 21st century.
And it does seem like the world is, or a large chunk of the world is moving towards Visual Studio Code, which is kind of interesting to me. Again, it's the JavaScript ecosystem on the one hand, and IDEs are one of those things that you want to be infinitely fast. You want them to just kind of immediately respond. And like, I mean, heck, there's someone I know, an old school game dev guy that still uses Visual Studio 6. And on a modern computer, everything is just absolutely instant on something like that because it was made to work on a computer that's 10,000 or 100,000 times slower. So just everything happens immediately. And all the modern systems just feel, they feel so crufty when it's like, oh, why is this refreshing the screen and moving around and updating over here and something blinks down there and you should update this. And there's, there are things that we've lost with that incredible flexibility, but lots of people get tons of value from it, and I am super happy that seems to be winning over even a lot of the old Vim and Emacs people, that they're kind of like, hey, Visual Studio Code's maybe, not so bad. That may be the final peacekeeping solution where everybody is reasonably happy with something like that.
So can you explain what a .plan file is and what role that played in your life? Does it still continue to play a role?
Back in the early days of id Software, one of our big things that was unique with what we did is I had adopted next stations, or kind of next step systems, from Steve Jobs's out in the woods away from Apple company, and they were basically, it was kind of interesting because I did not really have a background with the Unix system. So many of the people, they get immersed in that in college, and and that sets a lot of cultural expectations for them. And I didn't have any of that, but I knew that my background was I was a huge Apple II fanboy. I was always a little suspicious of the Mac. I was not really what kind of I wanted to go with. But when Steve Jobs left Apple and started Next, this computer did just seem like one of those amazing things from the future where it had all of this cool stuff in it. And we were still, back in those days, working on DOS. Everything blew up. You had reset buttons because your computer would get freeze. You doing development work literally dozens of times a day. Your computer was just rebooting constantly. And so this idea of, yes, any of the Unix workstations would have given a stable development platform where you don't crash and reboot all the time. But Next also had this really amazing graphical interface, and it was great for building tools, and it used Objective-C as the kind of an interesting dead end for things
Next
like that.
was Unix-based. It's at Objective-C, so it has a lot of the elements
that became Mac. I mean, the kind of reverse acquisition of Apple by Next, where that took over and became what the modern Mac system is.
And to find some of the developer, the tools and the whole community.
Yeah, you've still got, if you're programming on Apple stuff now, there's still all these NS somethings, which was originally Next Step objects of different kinds of things. But one of the aspects of those Unix systems was they had this notion of a .plan file, where a dot file is an invisible file, usually in your home directory or something. And there was a trivial server running on most Unix systems at the time that when somebody ran a trivial little command called finger, you could do finger and then somebody's address. It could be anywhere on the internet if you were connected correctly. Then all that server would do was read the .plan file in that user's home directory and then just spit it out to you. And originally the idea was that could be whether you're on vacation, what your current project was. It's supposed to be like the plan of what you're doing. And people would use it for various purposes, but all it did was dump that file over to the terminal of whoever issued the finger command. And at one point, I started just keeping a list of what I was doing in there, which would be what I was working on in the day, and I would have this little syntax I kind of got to myself about, here's something that I'm working on, I put a star when I finish it, I could have a few other little bits of punctuation, and at the time, it started off as being just like my to-do list, and it would be these trivial, obscure little things like fixed something with collision detection code, made Imp Fireball do something different, and just little one-liners that people that were following the games could kind of decipher. But I did wind up starting to write much more in-depth things. I would have little notes of thoughts and insights, and then I would eventually start having little essays I would sometimes dump into the .plan files, interspersed with the work logs of things that I was doing. So in some ways, it was like a super early proto-blog where I was just kind of dumping out what I was working on, but it was interesting enough that there were a lot of people that were interested in this. So most of the people didn't have Unix workstations, so there were the websites back in the day that would follow the Unix-based development that would basically make a little service that would go grab all the changes, and then people could just get it with a web browser. And there was a period where, like, all of the little kind of Dallas gaming diaspora of people that were at all in that orbit, there were a couple dozen plan files going on, this was some years before blogging really became kind of a thing. And it was kind of a premonition of sort of the way things would go. And there was, it's all been collected, it's available online in different places, and it's kind of fun to go back and look through what I was thinking, what I was doing in the different areas.
Have you had a chance to look back? Is there some interesting, very low-level specific to-do items, maybe things you've never completed, all that kind of stuff, and high-level philosophical essay type of stuff?
There's some good stuff on both, where a lot of it was low-level nitpicky details about game dev, and I've learned enough things where there's no project that I worked on that I couldn't go back and do a better job on now. I mean, you learn things, hopefully, if you're doing it right, you learn things as you get older, and you should be able to do a better job at all of the early things. And there's stuff in Wolfenstein Doom Quake that's like, oh, clearly I could go back and do a better job at this, whether it's something in the rendering engine side or how I implemented the monster behaviors or managed resources.
So you see the flaws in your thinking now? Looking back?
Yeah, I do. I mean, sometimes I'll get I'll look at it and say, yeah, I had a pretty clear view of I was doing good work there. And I haven't really hit the point where there was another programmer, Graham Devine, who he had worked at id and Seventh Guest, and he made some comment one time where he said he looked back at some of his old notes and he was like, wow, I was really smart back then. And I don't hit that so much where, I mean, I look at it and I always know that, yeah, there's all the, with aging, you get certain changes in how you're able to work problems, but all of the problems that I've worked, I'm sure that I could do a better job on all of them.
Oh, wow. So you could still step right in. If you could travel back in time and talk to that guy, you would teach him a few things.
Yeah, absolutely.
That's awesome. What about the high-level philosophical stuff? Is there some insights that stand out that you remember?
There's things that I was understanding about development and in the industry and so on that were in a more primitive stage where I definitely learned a lot more in the later years about business and organization and team structure there were definitely things that I was not the best person or even a very good person about managing, like how a team should operate internally, how people should work together. I was just, just get out of my way and let me work on the code and do this. And more I've learned how, in the larger scheme of things, how sometimes relatively unimportant some of those things are, where it is this user value generation that's the overarching importance for all of that. And I didn't necessarily have my eye on that ball correctly through a lot of my my earlier years, and there's things that I could have gotten more out of people handling things in different ways. I could have made in some ways more successful products by following things in different ways. There's mistakes that we made that we couldn't really have known how things would have worked out, but it was interesting to see in later years companies like Activision showing that, hey, you really can just do the same game, make it better every year. And you can look at that from a negative standpoint and say, oh, that's just being derivative and all that. But if you step back again and say, it's like, no, are the people buying it still enjoying it? Are they enjoying it more than what they might have bought otherwise? And you can say, no, that's actually a great value creation engine to do that in other positions where you can. Don't be forced into reinventing everything just because you think that you need to. Lots of things about this that could be done better. But the technical work, kind of technical visionary type stuff that I laid out, I still feel pretty good about. There's some classic old ones about my defending of OpenGL versus UPV, which turned out to be one of the more probably important momentous things there, where it was always a rearguard action on Windows where Microsoft was just not going to let that win. But when I look back on it now, that fight to keep OpenGL relevant for a number of years there meant that OpenGL was there when mobile started happening, and OpenGL ES was the thing that drove all of the acceleration of the mobile industry. And it's really only in the last few years, as Apple's moved to Metal and some of the other companies have moved to Vulkan, that's moved away. But really stepping back and looking at it, it's like, yeah, I sold tens of millions of games for different things, but billions and billions of devices wound up with an appropriate, capable graphics API due in no small part to me thinking that was really important, that we not just give up and use Microsoft's at that time really terrible APIs. The thing about Microsoft is the APIs don't stay there. They were terrible at the start, but a few versions on, they were actually quite good. And there was a completely fair argument to be made that by the time DX9 was out, it was probably a better programming environment than OpenGL. But it was still a wonderful, good thing that we had an open standard that could show up on Linux and Android and iOS, and eventually WebGL still to this day. So that was one that would be on my greatest hits list of things that I kind of pushed.
Impact it had on billions of devices. Yes, we'll talk about it. Can you tell the origin story of id Software? Again, one of the greatest game developer companies ever. Created Wolfenstein 3D, games that define my life in many ways. As a thing that made me realize what computers are capable of in terms of graphics, in terms of performance. It just unlocked something deep in me and understanding what these machines are all about. That games can do that. So Wolfenstein 3D, Doom, Quake, and just all the incredible engineering into that. So how did it all start?
So I'll caveat up front that I usually don't consider myself the historian of the software side of things. I usually do kind of point people at John Romero for stories about the early days where I've never been, I've commented that I'm a remarkably unsentimental person in some ways, where I don't really spend a lot of time unless I'm explicitly prodded to go back and think about the early days of things. And I didn't necessarily make the effort to archive everything exactly in my brain. And the more that I work on machine learning and AI and the aspects of memory and how when you go back and polish certain things, it's not necessarily exactly the way it happened. But, having said all of that, from my view, the way everything happened that led up to that was after I was an adult, I had taken a few college classes, deciding to drop out. I was hard traveled in contract programming, really struggling to kind of keep groceries and pay my rent. And the company that I was doing the most work for was a company called Soft Disk Publishing, which had the sounds bizarre now business model of monthly subscription software. Before there was an internet that people could connect to and get software, you would pay a certain amount, and every month they would send you a disk that had some random software. And people that were into computers thought this was kind of cool. They had different ones for the Apple II, the 2GS, the PC, the Mac, the Amiga, lots of different things. It was a quirky little business, but I was doing a lot of contract programming for them. I'd write tiny little games and sell them for $300, $500. And one of the things that I was doing, again, to keep my head above water here, was I decided that I could make one program and I could port it to multiple systems. I would write a game like Dark Design or Catacombs, and I would develop it on the Apple II, the 2GS, and the IBM PC, which apparently was the thing that really kind of piqued the attention of the people working down there. Like Jay Wilder was my primary editor, and Tom Hall was a secondary editor, and they kept asking me, it's like, hey, you should come down and work for us. And I pushed it off a couple times because I was really enjoying my freedom of being off on my own, even if I was barely getting by. I loved it. I was doing nothing but programming all day. But I did have enough close scrapes with, like, damn, I'm just really out of money that maybe I should get an actual job rather than contracting these kind of one-at-a-time things. And Jay Wilbur was great. He was, like, FedExing me the checks when I would need them to kind of get over whatever hump I was at. So I finally took them up on their offer to come down to Shreveport, Louisiana. I was in Kansas City at the time. Drove down through the Ozarks and everything down to Louisiana and saw the soft disk offices, went through, talked to a bunch of people, met the people I had been working with remotely at that time. But the most important thing for me was I met two programmers there, John Romero and Lane Roth, that for the first time ever, I had met programmers that knew more cool stuff than I did, where the world was just different back then. I was in Kansas City. It was one of those smartest kid in the school, does all the computer stuff. The teachers don't have anything to teach him. But all I had to learn from was these few books at the library. It was not much at all. And there were some aspects of programming that were kind of black magic. Like, oh, he knows how to format a track on a low-level drive programming interface. And this was, I was still not at all sure I was going to take the job, but I met these awesome programmers that were doing cool stuff on Maryland Ocean Virgin Systems, so many different games ahead of time that I did kind of quickly decide, like, yeah, I'll go take the job. And I settled down there, moved in, and started working on more little projects. And the first kind of big change that happened down there was the company wanted to make a PC gaming-focused subscription. Just like all their others, the same formula that they used for everything. Pay a monthly fee and you'll get a disc with 1 or 2 games just every month. And no choice in what you get, but we think it'll be fun. And that was the model they were comfortable with, and said, all right, we're going to start this Gamer's Edge department. And all of us that were interested in that, like me, Romero, Tom Hall was kind of helping us from his side of things. Jay would peek in, and we had a few other programmers working with us at the time. And we were going to just start making games, just the same model. And we dived in, and it was fantastic.
You have to make new games
every month.
Every month.
Yeah. And this, in retrospect, looking back at it, that sense that I'd done all this contract programming, and John Romero had done like far more of this, where he had done one of his teaching himself efforts was he made a game for every letter of the alphabet. It's that sense of like, I'm just going to go make 26 different games, give them a different theme. And you learn so much when you go through and you crank these things out, like on a bi-weekly, monthly basis, something like that.
From start to finish. Yeah. So it's not like just an idea. It's not just from the very beginning to the very end. It's done. It has to be done. There's no delaying. It's done.
Got deadlines. And that kind of rapid iteration, pressure cooker environment was super important for all of us developing the skills that that brought us to where we eventually went to. I mean, people would say like in the history of the Beatles, like it wasn't them being the Beatles, it was them playing all of these other early works, that opportunity to craft all of their skills before they were famous, that was very critical to their later successes. And I think there's a lot of that here where we did these games that nobody remembers, lots of little things that contributed to building up the skill set of the things that actually did make us famous.
Yeah, the Dostoevsky wrote The Gambler. Had to write it in a month just to make money. And nobody remembers that probably because he had to figure out, it's literally, he didn't have enough time to write it fast enough. They had to come up with hacks. It was literally
it comes down to that point where pressure and limitation of resources is surprisingly important. And it's counterintuitive in a lot of ways where you just think that if you've got all the time in the world and you've got all the resources in the world, of course you're going to get something better. But sometimes it really does work out that the innovations and other necessity, and where you can resource constraints and you have to do things when you don't have a choice. It's surprising what you can do.
Is there any good games written in that time, would you say?
Some of them are still fun to go back and play, where you get they were all about kind of the more modern term is game feel, about how just the exact feel that things, it's not the grand strategy of the design, but how running and jumping and shooting and those things feel in the moment. And some of those are still, you sat down out on the internet, so it's a little bit different. It doesn't have the same movement feel, but you move over and you bang, jump, bang. Hey, that's kind of cool still.
So you can get lost in the rhythm of the game, like is that what you mean by feel? Is it just like there's something about it that pulls you in?
Nowadays, again, people talk about compulsion loops and things where it's that that sense of exactly what you're doing, what your fingers are doing on the keyboard, what your eyes are seeing, and there are going to be these sequences of things. Grab the loot, shoot the monster, jump over the obstacle, get to the end of the level. These are eternal aspects of game design in a lot of ways, but there are better and worse ways to do all of them, and we did so many of these games that it was, we got a lot of practice with it. So one of the kind of weird things that was happening at this time is John Romero was getting some strange fan mail. And back in the days, this was before email, so we literally got letters sometimes and telling him, oh, I want to talk to you about your games, I want to reach out, different things. And eventually it turned out that these were all coming from Scott Miller at Apogee Software. And he was reaching out through, he didn't think he could contact John directly, that he would get intercepted, so he was trying to get him to contact him through like back channel fan mail, because he basically was saying, hey, I'm making all this money on shareware games. I want you to make shareware games, because he had seen some of the games that Romero had done. And, you know, we looked at Scott Miller's games and we didn't think they were very good. We're like, that can't be making the kind of money that he's saying he's making 10 grand or something. Off of this game. And we really thought that he was full of shit, that it was a lie trying to get him into this. But so that was kind of going on at at one level. And it was funny the moment when Romero realized that he had some of these letters pinned up on his wall with like all of his fans, and then we noticed that they all had the same return address with different names on them, which was a little bit of a two-edged sword there.
Trying to figure out the puzzle late on how to perform.
Yeah, what happened after kind of coincident with that was I was working on a lot of the new technologies where I was now full on the IBM PC for the first time, where I was really a long holdout on Apple II forever, and I loved my Apple II. It was the computer I always wished I had when I was growing up, and when I finally did have one, I was kind of clinging on to that well past its sort of good use by.
Is it the best computer ever made, can you say?
I wouldn't make judgments like that about it, but it was positioned in such a way, especially in school systems, that it impacted a whole lot of American programmers, at least, where there was programs that the Apple IIs got into the schools, and they had enough capability that lots of interesting things happened with them. In Europe, it was different. You had your Amigas and Ataris and, Acorns in the UK and things that had different things. But in the United States, it was probably the Apple II made the most impact for a lot of programmers of my generation. But so I was really digging into the IBM, and this was even more so with the code of those things. I moved to another city where I didn't know anybody that I wasn't working with. I had a little apartment, and then at Softisk, again, the things that drew me to it, I had a couple programmers who knew more than I did, and they had a library. They had a set of books, a set of magazines, so a couple of years of magazines, Dr. Dobbs Journal, and all of these magazines that had information. And so I was just in total immersion mode. It was eat, breathe, sleep, computer programming, particularly the IBM, for everything that I was doing. And I was digging into a lot of these low-level hardware details that people weren't usually digging into. The way the IBM EGA cards, which was fun for me. I hadn't had experience with things at that level. And back then, you could get hardware documentation down at the register level. This is where the CRTC register is. This is how the color registers work and how the different things are applied. And they were designed for a certain reason. They were designed for an application. They had an intended use in mind. But I was starting to look at other ways that they could perhaps be exploited that they weren't initially intended for.
Could you comment on, like, first of all, what operating system was there? What instruction set was it? Like, what are we talking about?
So this was DOS and x86. So 16-bit 8086. The 286s were there, and 386s existed. They were rare. We had a couple for our development systems, but we were still targeting the more broad. It was all DOS 16-bit. None of this was kind of DOS extenders and things.
How different is it from the system today? Is it kind of a precursor that's similar?
Very little. If you open up command.e on Windows, you see some of the remnants of all of that, but it was a different world. It was the 640K is enough world, and nothing was protected. It crashed all the time. You had TSRs or terminate and stay resident hacks on top of things that would cause configuration problems. All the hardware was manually configured in your auto exec. So it was a very different world. But
the code is still the same, similar.
You could still write it. My earliest code there was written in Pascal. That was what I had learned kind of at an earlier
Pascal?
point.
So between BASIC and C++, there was Pascal.
So when BASIC assembly language, and some of my my intermediate stuff was, well, you had to for performance. BASIC was just too slow. So most of the work that I was doing as a contract programmer in my teenage years was assembly language.
Wait, you wrote games in assembly?
Yeah, complete games in assembly language. And it's thousands and thousands of lines of three-letter acronyms, the instructions.
You don't earn the, once again, greatest programmer ever label without being able to write a game in assembly. Okay.
But that's good. Everybody wrote their, everybody serious wrote their games in assembly language. It was kind of a...
Serious. See what he said?
Yeah.
Everybody's serious.
It was an outlier to use Pascal a little bit, where there was one famous program called Wizardry. It was one of the great early role-playing games that was written in Pascal, but it was almost nothing to use Pascal there. But I did learn Pascal, and I remember doing all of my, like to this day, I sketch in data structures. When I'm thinking about something, I'll open up a file and I'll start writing structure definitions and how data is going to be laid out. And Pascal was kind of formative to that, because I remember designing my RPGs in Pascal record structures and things like that. And so I had gotten the Pascal compiler for the Apple IIgs that I could work on, and the first IBM game that I developed, I did in Pascal. And that's actually kind of an interesting story, again, talking about the constraints and resources, where I had an Apple IIgs, I didn't have an IBM PC. I wanted to port my applications to IBM because I thought I could make more money on it. So what I wound up doing was I rented a PC for a week and bought a copy of Turbo Pascal. And so I had a hard 1 week, and this was cutting into what minimal profit margin I had there. I had this computer for a week. I had to get my program ported before I had to return the PC. And that was kind of the first thing that I had done on the IBM PC, what led me to taking the job in the software side.
And Turbo Pascal, how's that different from regular Pascal? Is it different compiler or something like that?
So it was a product of Borland, which before Microsoft kind of killed them, they were the hot stuff developer tools company. You had Borland, Turbo Pascal, and Turbo C, and Turbo Prolog. I mean, all the different things. But what they did was they took a supremely pragmatic approach of making something useful. It was one of these great examples where Pascal was an academic language, and you had things like the UCSDP system that Wizardry was actually written in, that they did manage to make a game with that, but it was not a super practical system. While Turbo Pascal was called Turbo because it was blazingly fast to compile. I mean, really ridiculously 10 to 20 times faster than most other compilers at the time. But it also had very pragmatic access to, look, you can just poke at the hardware in these different ways, and we have libraries that let you do things. And it was a perfectly good way to write games. And this is one of those things where people have talked about different paths that computer development could have taken, where C took over the world for reasons that came out of Unix and eventually Linux. And that was not a foregone conclusion at all. And people can make real, reasoned, rational arguments that the world might have been better if it had gone a Pascal route. I'm somewhat agnostic on that, where I do know from experience it was perfectly good enough to do that. And it had some fundamental improvements, like it had range-checked arrays as an option there, which could avoid many of C's real hazards that happened in a security space. But C won. They were basically operating at about the same level of abstraction. It was a systems programming language. But
you said Pascal had more emphasis on data structures. Actually, in the tree of languages, did Pascal come before C?
They were pretty contemporaneous. So Pascal's lineage went to Modula 2 and eventually Oberon, which was another Nicholas Word kind of experimental language. But they were all good enough at that level. Now, some of the classic academic-oriented Pascal were just missing fundamental things like, oh, you can't access this core system thing because we're just using it to teach students. But Turbo Pascal showed that only modest changes to it really did make it a completely capable language. And it had some reasons why you could implement it as a single-pass compiler, so it could be way, way faster, although less scope for optimizations if you do it that way. And it did have some range checking options. It had a little bit better typing capability, had properly typed these sorts of things, and other stuff that C lacked. But C was also clearly good enough, and it wound up with a huge inertia from the ecosystem. Like that.
Garbage collection?
No, it was not garbage collected.
Same kind of
same manual. So you could still have your use after freeze and all those other problems, but over just getting rid of array orders, at least if you were compiled with that, certainly would have avoided that. You couldn't have a lot of them. But so anyways, that was the next thing I had to learn, because C was where it seemed like most of the things were going. So I abandoned Pascal and I started working in C. I started hacking on these hardware things, just dealing with the graphics controllers and the EGA systems. And what we most wanted to do, so at that time we were sitting in our darkened office playing all the different console video games. We were figuring out what do we want to use and what games do we want to make for our Gamer's Edge product there. And so we had one of the first Super Nintendos sitting there, and we had an older Nintendo, looking at all those games. And the core thing that those consoles did that you just didn't get on the PC games was this ability to have a massive scrolling world, where most of the games that you would make on the PC and earlier personal computers would be a static screen. You move little things around on it, and you interact like that. Maybe you go to additional screens as you move, but arcade games and consoles had this wonderful ability to just have a big world that you're slowly moving you into through. And that was, for those types of games, the kind of action, exploration, adventure games, that was a super, super important thing, and PC games just didn't do that. And what I had come across was a couple different techniques for implementing that on the PC. And they're not hard, complicated things. explain them now. They're pretty straightforward, but just nobody was doing it.
You sound like Einstein describing his 5 papers is pretty straightforward. I understand, but they're nevertheless revolutionary. So side scrolling is a game changer.
Yeah, it's
a genius invention.
Side or vertical, and some of the consoles had different limitations about you could do one but not the other, and there were similar things going on as advancements even in the console space, where you have like the original Mario game was like just horizontal scrolling, and then later Mario games added vertical aspects to it and different things that that you were doing to explore, kind of expand the capabilities there. And so much of the early game design for decades was removing limitations, letting you do things that you envisioned as a designer, you wanted the player to experience, but the hardware just couldn't really, or you didn't know how to make it happen. It felt impossible.
You can imagine that you want to create like this big world through which you can side scroll, like through which you can walk. And then you ask yourself the question, how do I actually build that in a way that's like the latency is low enough, the hardware can actually deliver that in such a way that it's a compelling.
Yeah, and we knew what we wanted to do because we were playing all of these console games, playing all these Nintendo games and arcade games. Clearly, there was a whole world of awesome things that we just couldn't do on PC, at least initially. Because every programmer can tell, it's like if you want to scroll, you just redraw the whole screen, but then it turns out, well, you're going 5 frames per second. That's not an interactive, fun experience. You want to be going 30 or 60 frames per second or something, and it just didn't feel like that was possible. It felt like the PC had to get 5 times faster before you could make playable games. And interestingly, I wound up with 2 completely different solutions for the scrolling problem. And this is a theme that runs through everything, where all of these big technical advancements, it turns out there's always a couple different ways of doing it. And it's not like you found the one true way of doing it. And we'll see this as we go into 3D games and things later. But so the first set of scrolling tricks that I got was, the hardware had this ability to, you could shift like inside the window of memory. So the EGA cards at the time had 256 kilobytes of memory, and it was awkwardly set up in this planar format where instead of having 256 or 24 million colors, you had 16 colors, which is 4 bits. So you had 4-bit planes, 64K a piece. Of course, 64K is a nice round number for 16-bit addressing. So your graphics card had a 16-bit window that you could look at, and you could tell it to start the video scan out anywhere inside. So there were a couple games that had taken this approach of you could make a 2x2 screen or a 1x4 screen, and you could do scrolling really easily like that. You could just lay it all out and just pan around there, but you just couldn't make it any bigger because that's all the memory that was there. The first insight to the scrolling that I had was, well, if we make a screen that's just one tile large, we usually had tiles that were 16 pixels by 16 pixels, a little classic Mario block that you run into, lots of art gets drawn out, and your screen is a certain number of tiles. But if you had one little buffer outside of it, you can easily pan around inside that 16 pixel region. It's perfectly smooth. But then what happens if you get to the edge and you want to keep going? The first way to do so was what I call adaptive tile compression, which was really just a matter of you get to the edge and then you go back to the original point and then only change the tiles that are different between where it was. In most of the games at the time, if you think about sort of your classic Super Mario Brothers games, you've got big fields of blue sky, long rows of the same brick texture, and there's a lot of commonality. It's kind of like a data compression thing. If you take the screen and you set it down on top of each other, in general, only about 10% of the tiles were actually different. So this was a way to go ahead and say, well, I'm going to move it back, and I'm only going to change those 10, 20, whatever percent tiles there. And that meant that it was essentially 5 times faster if you were redrawing all those tiles. And that worked well enough for us to do a bunch of these games for Gamer's Edge. We had a lot of these scrolling games like Streamhacks and Shadow Knights and things like that we were cranking out at this high rate that had this scrolling effect on it. And it worked well enough. There were design challenges there where if you made, the worst case, you made a checkerboard over the entire screen. You scroll over one and every single tile changes and your frame rate's now 5 frames per second because it had to redraw everything. So the designers had a little bit that they had to worry about. They had to make these relatively flexible levels, but it was still pretty magical. It was something that we haven't seen before. And the first thing that we wound up doing with that was I had just gotten this working, and Tom Hall was sitting there with me, and we were looking over at our Super Nintendo on the side there with Super Mario 3 running, and we had the technology, we had the tools set up there, and we stayed up all night, and we basically cloned the first level of Super Mario Brothers.
Performance-wise as well?
Yeah, and so we had our little character running and jumping in there. It wasn't It was close to pixel accurate as far as all of the backgrounds and everything, but the gaming was just stuff that we cobbled together from previous games that I had written. I just kind of like really kit bashed the whole thing together to make this demo. And that was one of the rare cases when I said I don't usually do these all-night programming things. There's probably only 2 memorable ones that I can think of. One was all-nighter to go ahead and get our Dangerous Dave and copyright infringement is how we titled it, because we had a game called Dangerous Dave that's running around with shotgun shooting things, and we were just taking our most beloved game at the time there, the Super Mario 3, and sort of sticking Dave inside that with this new scrolling technology that was going perfectly smooth for for the as it ran. And Tom and I just kind of blearily the next morning, kind of left, and we left a disc on the desk for John Romero and Jay Wilbur to see, and just said, "Run this." And we eventually made it back in later in the day, and it was they grabbed us and pulled us into the room, and that was the point where they were like, "We got to do something with this. We're going to make a company. We're going to go make our own games." Where this was something that we were able to just kind of hit them with a hammer of an experience, like, wow, this is just like so much cooler than what we thought was possible there. And initially, we tried to get Nintendo to let us make Super Mario 3 on the PC. That's really what we wanted to do. We were like, hey, we can finish this. It's line of sight for this will be great. And we sent something to Nintendo, and we heard that it did get looked at in Japan, and they just weren't interested in that. But that's another one of those, life could have gone a very different way, where we could have been like Nintendo's house PC team, at that point.
And define the direction of, Doom and Quake could have been a Nintendo creation.
Yeah. So at the same time that we were just doing our first scrolling demos, we reached out to everywhere, and it wasn't a crippled demo where the first episode of all of these trilogies, it was a real complete game, and probably 20 times as many people played that part of it, thought they had a great game, had fond memories of it, but never paid us a dime. But enough people were happy with that, where it was really quite successful. These early games that we didn't think very much of compared to commercial quality games, but they were doing really good business. Some fairly crude things, and it was good business. People enjoyed it, and it wasn't like you were taking a crapshoot on what you were getting. You just played a third of the experience, and you loved it enough to hand write out a check and put it in an envelope and address it and send it out to Apogee to get the rest of it. So it was a really pretty feel-good business prospect there, because everybody was happy. They knew what they were getting, and they sent it in. They would send in fan mail. If you go into the trouble of addressing a letter and filling out an envelope, you write something in it, and there were just the literal bags of fan mail for the shareware games. So people loved them.
I should mention that for you, the definition of wealth is being able to have pizza whenever you want. For me, there was a dream, because I would play shareware games over and over, build the part that was free over and over, and it was a very deeply fulfilling experience. But I dreamed of a time when I could actually afford the full experience, and this is kind of this dreamland beyond the horizon, where you could find out what else is there. In some sense, even just playing the shareware was the limitation of that. Life is limited. Eventually we all die. In that way, shareware was like somehow really fulfilling to have this kind of mysterious thing beyond what's free or was there. It's kind of, I don't know, maybe it's because a part of my childhood is playing shareware games. That was a really fulfilling experience. It's so interesting how that model still brought joy to so many people.
Yeah,
the 20x people that played it.
Yeah, I felt very good about that, and I would run into people, it's like, that would say, oh, I love that game, that you had early on, Commander Keen, whatever, and no, they meant just the first episode that they got to see everywhere.
That's me. I played the crap out of Commander Keen.
And that was all good.
Yeah.
But so we were in this position where Scott Miller was just fronting us cash, saying, yeah, make a game. But we did not properly pull the trigger and say, all right, we're quitting our jobs. We were like, we're going to do both. We're going to keep working at Softdisk, working on this, and then we're going to go ahead and make a new game for Apogee at the same time. And this eventually did lead to some legal problems. We had trouble. It all got worked out in the end, but it was not a good call at that time.
And your legal mind at the time was not stellar. You were not thinking in legal terms.
No, I definitely wasn't. None of us were. And in hindsight, yeah, it's like, how did we think we were going to get away with, like, even using our work computers to write software for, our breakaway new company? It was not a good plan.
How did Commander Keen?
So the design process we would start from, we had some idea of what we wanted to do. We wanted to do a Mario-like game. It was going to be a side-scroller. It was going to use the technology. We had some sense of what it would have to look like because of the limitations of this adaptive tile refresh technology. It had to have fields of relatively constant tiles. You couldn't just paint up a background and then move that around. The early design, or all the design for Commander Keen, really came from Tom Hall, where he was he was kind of the main creative mind for the early id Software stuff, where we had an interesting division of things where Tom was all creative and design, I was all programming. John Romero was an interesting bridge where he was both a very good programmer and also a very good designer and artist and kind of straddled between the areas. But Commander Keen was very much Tom Hall's baby, and he came up with all the design and backstory for the different things of kind of a mad scientist little kid with, building a rocket ship and a zap gun and visiting alien worlds and doing all of this, that the background that we lay the game inside of. And there's not a whole lot to any of these things. Design for us was always just what we needed to do to make the game that was going to be so much fun to play. And we laid out our first trilogy of games. The shareware formula was going to be 3 pieces. We made Commander Keen 1, 2, and 3. And we just really started busting on all that work, and it went together really quickly. It was like 3 months or something, that while we were still making games every month for Gamer's Edge, we were sharing technology between that. I'd write a bunch of code for this, and we'd just kind of use it for both. Again, not a particularly good idea there that had consequences for us, but in 3 months, we got our first game out, and all of a sudden it was 3 times as successful as the most successful thing Apogee had before, and we were making like $30,000 a month immediately from the Commander Keen stuff. And that was, again, a surprise to us. It was more than we thought that was gonna make. And we said, well, we're gonna certainly roll into another set of titles from this. And in that 3 months, I had come up with a much better way of doing the scrolling technology that was not the adaptive tile refresh, which in some ways was even simpler. And these things, so many of the great ideas of technology are things that are back of the envelope designs. I make this comment about modern machine learning, where all the things that are really important practically in the last decade are, each of them fits on the back of an envelope. There are these simple little things. They're not super dense, hard to understand technologies. And so the second scrolling trick was just a matter of like, okay, we know we've got this 64K window. And the question was always like, well, you could make a 2x2, but you can't go off the edge. But I finally asked, well, what actually happens if you just go off the edge? If you take your start and you say, it's like, okay, I can move over, I'm scrolling, I can move over, I can move down, I'm scrolling. I get to what should be the bottom of the memory window. It's like, well, what if I just keep going? And I say, I'm going to start at, what happens if I start at FFFE at the very end of the 64K block? And it turns out it just wraps back around to the top of the block.
Mhm.
And I'm like, oh, well, this makes everything easy. You can just scroll the screen everywhere, and all you have to draw is just one new line of tiles, whichever thing you expose. It might be unaligned off various parts of the screen memory, but it just works. That no longer had the problem of you had to have fields of the similar colors, because it doesn't matter what you're doing. You could be having a completely unique world, and you're just drawing the new strip as it comes on.
But it might be, like you said, unaligned, so it can be all over the place.
Yeah, and it turns out it doesn't matter. I would have 2 page-flipped screens. As long as they didn't overlap, they moved in series through this 2-dimensional window of graphics. And that was one of those like, well, this is so simple. This just works. It's faster. It seemed like there was no downside. Funny thing was, it turned out after we shipped titles with this, there were what they called super VGA cards, the cards that would allow higher resolutions and different features that the standard ones didn't. And on some of those cards, this was a weird compatibility quirk, again, because nobody thought this was not what it was designed to do. And some of those cards had more memory. They had more than just 256K in 4 planes. They had 512K or a megabyte.
Mhm.
And on some of those cards, I scroll my window down, and then it goes into uninitialized memory that actually exists there rather than wrapping back around at the top. And then I was in the tough position of, do I have to track every single one of these? And it was a madhouse back then. There were 20 different video card vendors with all slightly different implementations of their non-standard functionality. So either I needed to natively program all of the VGA cards there to map in that memory and keep scrolling down through all of that, or I kind of punted and took the easy solution of, when you finally did run to the edge of the screen, I accepted a hitch and just copied the whole screen up there. So on some of those cards, it was a compatibility mode. In the normal ones, when it all worked fine, everything was just beautifully smooth. But if you had one of those cards where it did not wrap the way I wanted it to, you'd be scrolling around, and then eventually you'd have a little hitch where 200 milliseconds or something that was not super smooth.
Yeah,
as
it froze a little
yeah.
bit. And so it's a binary thing. Is it one of the standard screens, or is it one of the weird ones, the super VGA ones?
Yeah.
Okay.
And so we would default to, and I think that was one of those that changed over the kind of course of deployment, where early on we would have a normal mode, and then you would enable the compatibility flag if your screen did this crazy flickery thing when you got to a certain point in the game. And then later, I think it probably got enabled by default as just more and more of the cards kind of did not do exactly the right thing. And that's the two-edged sword of doing unconventional things with technology, where you can find something that nobody thought about doing that kind of scrolling trick when they set up those cards. But the fact that nobody thought that was the primary reason, when I was relying on that, then I wound up being broken on some of the later cards.
Let me take a bit of a tangent, but ask you about the hacker ethic, because you mentioned shareware. It's an interesting world, the world of people that make money, business, and the people that build systems, the engineers. And what is the hacker ethic? You've been a man of the people, and you've embodied at least a part of that ethic. What does it mean? What did it mean to you at the time? What does it mean to you today?
So Stephen Levy's book Hackers was a really formative book for me as a teenager. I mean, I read it several times, and there was all of the great lore of the early MIT era of hackers, and ending up at the end with, it kind of went through the early MIT hackers, and then the Silicon Valley hardware hackers, and then the game hackers in part 3. And at that time, as a teenager, I really was kind of bitter in some ways. Like, I thought I was born too late. I thought I missed the window there. And I really thought I belonged in that third section of that book with the game hackers. And they were talking about, the Williams at Sierra and Origin Systems with Richard Garriott. And it's like, I really wanted to be there. And I knew that was now a few years in the past. It was, it was not to be. But the early days, especially the early MIT hacker days, talking a lot about this sense of the hacker ethic, that there was this sense that it was about sharing information, being good, not keeping it to yourself, and that it's not a zero-sum game, that you can share something with another programmer and it doesn't take it away from you. You then have somebody else doing something. And I also think that there's an aspect of it where it's this ability to take joy in other people's accomplishments, where it's not the cutthroat bit of like, I have to be first, I have to be recognized as the one that did this in some way, but being able to see somebody else do something and say, holy shit, that's amazing, and just taking joy in the ability of something amazing that somebody else does. And the big thing that I was able to do through id Software was this ability to eventually release the source code for most of our, all of our really seminal game titles. And that was a stepping stone process where we were kind of surprised early on where people were able to hack the existing games. And of course, I had experience with that. I remember hacking my copies of Ultima, so I'd give myself, 9999 gold and raise my levels and, break out the sector editor. And so I was familiar with all of that. So it was with a smile when I started to see people doing that to our games. I am, making level editors for Commander Keen or hacking up Wolfenstein 3D. But I made the pitch internally that we should actually release our own tools for what we did, what we used to create the games. And that was a little bit debatable about, we'll give people a leg up. It's always like, what's that going to mean for the competition? Yeah. But the really hard pitch was to actually release the full source code for the games. And it was a balancing act with the other people inside the company, where it's interesting how the programmers generally did get, certainly the people that I worked closely with, they did kind of get that hacker ethic bit where you wanted to share your code. You were proud of it. You wanted other people to take it, do cool things with it. But interestingly, the broader game industry is a little more hesitant to embrace that than the group of people that we happen to have at id Software, where it was always a little interesting to me seeing how a lot of people in the game modding community were very possessive of their code. They did not want to share their code. They wanted it to be theirs. It was their, claim to fame. And that was much more like what we tended to see with artists, where, the artists understand something about credit and, wanting it to be known as their work. And a lot of the game programmers felt a little bit more like artists than like hacker programmers, in that it was about building something that maybe felt more like art to them than the more tool-based and exploration-based kind of hacking culture side of things.
Yeah, it's so interesting that this kind of fear that credit will not be sufficiently attributed to you.
And that's one of the things that I do bump into a lot, because I try not to go claim. I mean, it's easy for me to say because so much credit is heaped on me for the id Software side of things. But when people come up and they want to pick a fight and say, no, it's like that wasn't where first person gaming came from. And you can point to, some of things on obscure titles that I was never aware of, or like the old Play-Doh systems, or, each personal computer had something that was 3D-ish and moving around. And I'm and I'm happy to say it's like, no, I mean, I saw Battlezone and Star Wars in the arcades. I had seen 3D graphics. I had seen all these things. I'm standing on the shoulders of lots of other people, but sometimes these examples they pull out, it's like, I didn't know that existed. I mean, I had never heard of that before then. That didn't contribute to what I made, but there's plenty of stuff that did. And, I think there's good cases to be made that obviously Doom and Quake and Wolfenstein were formative examples for what everything that came after that. But I don't feel the need to go fight and claim primacy or initial invention of anything like that. But a lot of people do want to.
I think when you fight for the credit in that way, and it does go against the hacker ethic, you destroy something fundamental about the culture, about the community that builds cool stuff. I think credit ultimately, so I had this sort of, there's a famous wrestler in freestyle wrestling called Luis Arcegio. And he always preached that you should just focus on the art of the wrestling and let people write your story however they want. The highest form of the art is just focusing on the art, and that is something about the hacker ethic, is just focus on building cool stuff, sharing it with other cool people, and credit will get assigned correctly in the long arc of history.
I generally think that's true. You've got, there's some things there's a graphics technique that got labeled Carmack's reverse. Literally named it, and it turned out that I wasn't the first person to figure that out. Yeah. Like most scientific things or mathematical things, you wind up, it's like, oh, this other person had actually done that somewhat before. And then there's things that get attributed to me, like the inverse square root hack, that I actually didn't do. I flat out, that wasn't me. And it's like, it's weird how the mimetic power of the internet,
You're like the Mark Twain of programming.
Yes.
It's just everything just gets attributed to you now, even though you've never sought the credit of things. I mean, but part of the fact of the humility behind that is what attracts the attribution. Let's talk about a game. To me, one of the greatest games ever made. I know you could talk about doing Quake and so on, but to me, Wolfenstein 3D was like, wow. It blew my mind. So, how did Wolfenstein 3D come to be in terms of the programming, in terms of the design, in terms of some of the memorable technical challenges, and also, actually, just something you haven't mentioned is, how did these ideas come to be inside your mind? The adaptive side-scrolling, so the solutions to these technical challenges.
So I usually can introspectively pull back pretty detailed accounts of how technology solutions and design choices on my part came to be, where technically we had done 2 games, 3D games like that before, where Hover Tank was the first one, which had flat shaded walls but did have the scaled enemies inside it, and then Catacombs 3D, which had textured walls, scaled enemies, and some more functionality, like the disappearing walls and some other stuff. But what's really interesting from a game development standpoint is those games, Catacombs 3D, Hover Tank, and Wolfenstein, they literally used the same code for a lot of the character behavior that a 2D game that I had made earlier called Catacombs did, where it was an overhead view game, kind of like Gauntlet. You're running around and open up doors, pick up items, basic game stuff. And the thought was that this exact same game experience, just presented in a different perspective, it could be literally the same game, just with a different view into it, would have a dramatically different impact on the player.
So it wasn't a true 3D. You're saying that you can kind of fake it. You can scale enemies, meaning things that are farther away. You can make them smaller.
So from the game was a 2D map. Like all of our games use the same tool for creation. We use the same map editor for creating Keen as Wolfenstein and Hover Tank and Catacombs and all this stuff. So the game was a 2D grid made out of blocks, and you could say, well, these are walls, these are where the enemies start, then they start moving around. And these early games like Catacombs, you played it strictly in a 2D view. It was a scrolling 2D view, and that was kind of using an adaptive tile refresh at the time to be able to do something like that. And then the thought that these early games, all it did was take the same basic enemy logic, but instead of seeing it from the God's eye view on top, you were inside it and turning from side to side, yawing your view and moving forwards and backwards and side to side. And it's a striking thing where you always talk about wanting to isolate and factor changes in values, and this was one of those most pure cases there, where the rest of the game changed very little. It was our normal kind of change the colors on something and draw a different picture for it, but it's kind of the same thing, but the perspective changed in a really fundamental way, and it was dramatically different. I can remember the reactions where the artists Adrian that had been drawing the pictures for me. We had a cool big troll from Catacombs 3D, and we had these walls that you could get a key and you could make the blocks get the key. Really simple stuff. Blocks could either be there or not there, so our idea of a door was being able to make a set of blocks just disappear. And I remember the reaction where he had drawn these characters and he was slowly moving around, and like people had no experience with 3D navigation. It was all still keyboard. We didn't even have mice set up at that time, but slowly moving, going up, picked up a key, go to a wall, the wall disappears in a little animation, and there's a monster like right there, and he practically fell out of his chair. It was just like, ah! And games just didn't do that. You know, the games were the God's Eye view. You were a little invested in your little guy. You can be like, you know, happy or sad when things happen, but you just did not get that kind of startle reaction.
You weren't inside
something in your
the game.
face, something in the back of your brain, some reptile brain thing is just going, oh shit, something just happened. And that was one of those early points where it's like, yeah, this is going to make a difference. This is going to be powerful, and it's going to matter.
Were you able to imagine that in the idea stage, or no?
So, not that exact thing. So again, we had cases like the arcade games Battlezone and Star Wars that you could kind of see a 3D world and things coming at you, and you get some sense of it, but nothing had done the kind of worlds that we were doing and the sort of action-based things. 3D at the time was really largely about these simulation thoughts. And this is something that really might have trended differently if not for the id Software approach in the games, where there were flight simulators, there were driving simulators, you had like Hard Drive-In and Microsoft Flight Simulator, and these were doing 3D and general purpose 3D in ways that were more flexible than what we were doing with our games, but they were looked at as simulations. They weren't trying to necessarily be fast or responsive or letting you do kind of exciting maneuvers, because they were trying to simulate reality, and they were taking their cues from the big systems, the Evans and Sutherlands and the Silicon Graphics that were doing things. But we were taking our cues from console and arcade games. You know, we wanted things that were sort of quarter eaters, that were doing fast-paced things that you could smack you around rather than just smoothly gliding you from place to place. So
Quarter.
yeah. And you know, the funny thing is, so much that built into us that Wolfenstein still had lives, and you had like one of the biggest power-ups in all these games, like was an extra life, because you started off with 3 lives and you lose your lives and then it's game over. And there weren't save games in most of this stuff. It was, and it sounds almost crazy to say this, but it was an innovation in Doom to not have lives. You know, you could just play Doom as long as you wanted. You just restart at the start of the level, and why not? This is like, we aren't trying to take people's quarters. They've already paid for the entire game. We want them to have a good time. And you would have some, some old-timer purist that might think that there's something to the epic journey of making it to the end, having to restart all the way from the beginning after a certain number of tries. But no, more fun is had when you just let people kind of keep trying when they're stuck, rather than having to go all the way back and learn different things.
So you've recommended the book Game Engine Black Book, Wolfenstein 3D, for technical exploration of the game. So looking back 30 years, what are some memorable technical innovations that made this perspective shift into this world that's so immersive that scares you when a monster appears? What were some things you had to solve?
So one of the interesting things that come back to the theme of deadlines and resource constraints, the game Catacombs 3D, we were supposed to be shipping this for Gamer's Edge on a monthly cadence, and I had slipped. I was actually late. It slipped like 6 weeks, because this was texture mapped walls doing stuff that I hadn't done before. And at the 6-week point, it was still kind of glitchy and buggy. There were things that I knew that if you had a wall that was like almost edge on, you could slide over to it and you could see some things freak out or vanish or not work. And I hated that. But I was up against the wall. We had to ship the game. It was still a lot of fun to play. It was novel. Nobody had seen it. It gave you that startle reflex reaction. So it was worth shipping, but it had these things that I knew were kind of flaky and janky and not what I was really proud of. So one of the things that I did very differently in Wolfenstein was I went... Catacombs used almost a conventional thing where you had segments that were one-dimensional polygons, basically, that were clipped and back-faced and done kind of like a very crude 3D engine from the professionals, but I wasn't getting it done right. I was not doing a good enough job. I didn't really have line of sight to fix it right. There's stuff that, of course, I look back, it's like, oh, it's obvious how to do this, do the math right, do your clipping right, check all of this, how you handle the precision, but I did not know how to do that at that time. And
was that the first 3D engine you wrote, Catacombs 3D?
And Hover Tank had been a little bit before that, but that had the flat shaded walls. So the texture mapping on the walls was what was bringing in some of these challenges that was hard for me, and I couldn't solve it right at the time.
Can you describe what flat shading is and texture mapping?
So in the walls were solid color, one of 16 colors in Hover Tank. So that's easy, it's fast, you just draw the solid color for everything. Texture mapping is what we all see today, where you have an image that is stretched and distorted onto the walls or the surfaces that you're working with. And it was, it was a long time for me to just figure out how to do that without it distorting in the wrong ways. And I did not get it all exactly right in Catacombs, and I had these flaws. So that was important enough to me that rather than continuing to bang my head on that, and I wasn't positive I was going to get it, I went with a completely different approach for figuring out where the walls were, which was a ray casting approach, which I had done in Catacombs 3D. I had a bunch of C code trying to make this work right, and it wasn't working right. In Wolfenstein, I wound up going to a very small amount of assembly code. So in some ways, this should be a slower way of doing it, but by making it a smaller amount of work that I could more tightly optimize, it worked out, and Wolfenstein 3D was just absolutely rock solid. It was, nothing glitched in there. The game just was pretty much flawless through all of that. I was super proud of that. But eventually, like in the later games, I went back to the more span-based things where I could get more total efficiency once I really did figure out how to do it. So there were two sort of key technical things to Wolfenstein. One was this raycasting approach, which you still, to this day, you see people go and say, let's write a raycasting engine, because it's an understandable way of doing things that lets you make games very much like that. So you see raycasters in JavaScript, raycasters in Python, people that are basically going and re-implementing that approach to taking a tiled world and casting out into it. It works pretty well, but it's not the fastest way of doing it.
Can you describe what raycasting is?
So you start off and you've got your screen, which is 320 pixels across at the time if you haven't sized down the window for greater speed. And at every pixel, there's going to be an angle from you got your position in the world, and you're going to just run along that angle and keep going until you hit a block. So up to 320 times across there, it's going to throw a cast array out into the world from wherever your origin is until it runs into a wall, and then it can figure out exactly where on the wall it hits. The performance challenge of that is, as it's going out, every block it's crossing, it checks, is this a solid wall? So that means that in like the early Wolfenstein levels, you're in a small jail cell going out into a small hallway. It's super efficient for that, because you're only stepping across 3 or 4 blocks. But then if somebody makes a room that covers a map, you're limited to 64 by 64 blocks. If you made one room that was nothing but walls at the far space, it would go pretty slow, because it would be stepping across 80 tile tests or something along the way.
By the way, the physics of our universe seems to be computing this very thing. So this maps nicely to the actual physics of our world.
Yeah, you get like I follow a little bit of something like Stephen Wolfram's work on interconnected network information states of that, and it's beyond what I can have an informed opinion on. But it's interesting that people are considering things like that and have things that can back it up. There's whole different sets of interesting stuff there.
So Wolfenstein 3D had raycasting.
So the raycasting, and then the other kind of key aspect was what I called compiled scalars, where the idea of you saw this in the earlier classic arcade games like Space Harrier and stuff, where you would take a picture, which is normally drawn directly on the screen, and then if you have the ability to make it bigger or smaller, big chunky pixels or fizzily small drop sample pixels, that's the fundamental aspect of what our characters were doing in these 3D games. You would have, just like you might have drawn a tiny little character, but now we can make them really big, make them really small, move it around. That was the limited kind of 3D that we had for characters. To make them turn, there were literally 8 different views of them. You didn't actually have a 3D model that would rotate. You just had these cardboard cutouts. But that was good enough for that startle fight reaction, and it was kind of what we had to deal with there. So a straightforward approach to do that, you could just write out your doubly nested loop of you've got your stretch factor, and it's like you've got a point, you stretch by a little bit, it might be on the same pixel, it might be on the next pixel, it might have skipped a pixel. You could write that out, but it's not going to be fast enough, where especially you get a character for that right in your face, monster covering almost the entire screen. Doing that with a general purpose scaling routine would have just been much too slow. It would have worked when they're small characters, but then it would get slower and slower as they got closer to you. So right at the time when you most care about having a fast reaction time, the game would be chunking down. So the fastest possible way to draw pixels at that time was to, instead of saying I've got a general purpose version that can handle any scale, I used a program to make essentially 100 or more separate little programs that was optimized for, I will take an image and I will draw it 12 pixels tall. I'll take an image, I'll draw it 14 pixels tall, up by every 2 pixels even for that. So you would have the most optimized code so that in the normal case, where most of the world is fairly large, like the pixels are big, we did not have a lot of memory. So in most cases, that meant that you would load a pixel color and then you would store it multiple times. So that was faster than even copying an image in a normal conventional case, because most of the time the image is expanded. So instead of doing 1 read, 1 write for a simple copy, you might be doing 1 read and 3 or 4 writes as it got really big. And that had the beneficial aspect of just when you needed the performance most, when things are covering the screen, it was giving you the most acceleration for that.
By the way, were you able to understand this through thinking about it, or were you testing like the right speed? Like
So this again comes back to, I can find the antecedents for things like this. So back in the Apple II days, the graphics were essentially single bits at a time, and if you wanted to make your little spaceship, if you wanted to make it smoothly go across the world, if you just took the image and you drew it out at the next location, you would move by 7 pixels at a time, so it would go chunk, chunk, chunk. If you wanted to make it move smoothly, you actually had to make 7 versions of the ship that were pre-shifted. You could write a program that would shift it dynamically, but on a 1 megahertz processor, that's not going anywhere. So if you wanted to do a smooth-moving, fast-action game, you made separate versions of each of these sprites. Now, there were a few more tricks you could pull that if it still wasn't fast enough, you could make a compiled shape where instead of this program that normally copies an image and says, like, get this byte from here, store here, get this byte, store this byte, if you've got the memory space, you could say, I'm going to write the program that does nothing but draw this shape. It's going to be like, I'm going to load the immediate value 25, which is some bit pattern, and then I'm going to store that at this location. Rather than loading something from memory that would involve indexing registers and this other slow stuff, you could go ahead and say, no, I'm going to hard code the exact values of all of the images right into the program. This was always a horrible trade-off there. You didn't have much memory, and you didn't have much speed. But if you had something that you wanted to go really fast, you could turn it into a program. And that was, knowing about that technique is what made me think about some of these unwinding it for the PC, where people that didn't come from that background were less likely to think about that.
I mean, there's some deep parallel probably to human cognition as well. There's something about optimizing and compressing the processing of the new information that requires you to predict the possible ways in which the game or the world might unroll. And you have something like compiled scalar is always there. You have you have a prediction of how the world will unroll, and you have some kind of optimized data structure for that prediction, and then you modify it if the world turns out to be different, you modify it slightly.
As far as building out techniques, so much of the brain is about the associative context. You know, just when you learn something, it's in the context of something else, and you can have faint, tiny little hints of things. And I do think there are some deep things, around like sparse distributed memories and boosting. That's like if you can just be slightly above the noise floor of having some hint of something, you can have things refined into pulling the memory back up. So being a programmer and having a toolbox of like all of these things that I did in all of these previous lives of programming tasks, that still matters to me about how I'm able to pull up some of these things. Like in that case, it was something I did on the Apple II, then being relevant for the PC. And I have still cases when I would work on mobile development, then be like, okay, I did something like this back in the Doom days, but now it's a different environment, but I still have that pie. I can bring it in and transform it into what the world needs right now. And I do think that's actually one of the very core things with human cognition and brain-like function, is finding these ways. The brain is kind of everything everywhere all at once. It is just a set of all of this stuff that is just fetched back by these queries that go into it, and they can just be slightly above the noise floor with random noise in your neurons and synapses that are affecting exactly what gets pulled in.
So you're saying some of these very specific solutions for different games, you find that there's a kernel of a deep idea that's generalizable to other things.
Yeah, you can't predict what it's going to be, but that idea of, like, I called out that compiled shaders in the forward that I wrote for that the Game Engine Black Book as, it's kind of an endpoint of unrolling code, but that's one of those things that thinking about that and having that in your mind, and I'm sure there are some programmers that hear about that, think about it a little bit, it's kind of the mind-blown moment. It's like, oh, you can just turn all of that data into code, and nowadays, you have instruction cache issues, and that's not necessarily the best idea, but there are it's an idea that has power and has probably relevance in some other areas. Maybe it's in a hardware point of view that there's a way you approach building hardware that has that same, you don't even have to think about iterating, you just bake everything all the way into it in one place.
What is the story of how you came to program Doom? What are some memorable technical challenges or innovations within that game?
So the path that we went after Wolfenstein got out, and we were on this crazy arc where Keen 1 through 3, more success than we thought. Keen 4 through 6, even more success. Wolfenstein, even more success. So we were on this crazy trajectory for things. So actually, our first box commercial project was a Commander Keen game, but then Wolfenstein was going to have a game called Spear of Destiny, which was a commercial version, 60 new levels. So the rest of the team took the game engine pretty much as it was and started working on that. We got new monsters, but it's basically reskins of the things there. And there's a really interesting aspect about that I didn't appreciate until much, much later, about how Wolfenstein clearly did tap out its limit about what you want to play all the levels and a couple of our licensing, there was a hard creative wall that you did not really benefit much by continuing to beat on it. But a game like Doom and other more modern games, Minecraft or something, there's kind of a Turing completeness level of design freedom that you get in games that Wolfenstein clearly sat on one side of. You know, all the creative people in the world could not go and do a masterpiece just with the technology that Wolfenstein had. Wolfenstein could do Wolfenstein, but you really couldn't do something crazy and different. But it didn't take that much more capability to get to Wolfenstein with the freeform lines and a little bit more artistic freedom to get to the point where people still announce new Doom levels today, all these years after, without having completely tapped out the creativity.
How did you put it? Turing complete?
Like Turing complete design space.
Design space.
Where it's like, you know, we have the kind of computational universality on a lot of things and how different
for creativity
work. But yeah, there's things where a box can be too small, but above a certain point, you kind of are at the point where you really have almost unbounded creative ability there.
And Doom is the first time you cross that line.
Yeah, where there were thousands of Doom levels created, and some of them still have something new and interesting to say to the world about it.
Is that line, can you introspect what that line was? Is it in the design space? Is it something about the programming capabilities that you were able to add to the game?
So the graphics fidelity was a necessary part because the block limitations in Wolfenstein, what we had right there, was not enough, the full-scale blocks, although Minecraft really did show that perhaps blocks stacked in 3D and at 1/4 the scale of that, or 1/8 in volume, is then sufficient to have all of that. But the wall-sized blocks that we had in Wolfenstein was too much of a creative limitation. You know, we licensed the technology to a few other teams. None of them made, you know, too much of a dent with that. It just wasn't enough creative ability. But a little bit more, whether it was the variable floors and ceilings and arbitrary angles in Doom, or the smaller voxel blocks in Minecraft, is then enough to open it up to just worlds and worlds of new capabilities.
What is binary space partitioning?
So
which is one of the technologies.
Yeah, so jump around a little bit on the story path there.
Yes.
So while the team was working on Spear of Destiny for Wolfenstein,
Yes.
we had met another development team, Raven Software, while we were in Wisconsin, and they had RPG background, and I still kind of love that, and I offered to do a game engine for them, to let them do a 3D rendered RPG instead of like most RPG games were kind of hand-drawn. They made it look kind of 3D, but it was done just all with artist work rather than a real engine. And after Wolfenstein, this was still a tile-based world, but I added floors and ceilings and some lighting and the ability to have some sloped floors in different areas. And that was my intermediate step for a game called Shadowcaster. And it had slowed down enough. It was not fast enough to do our type of action things, so they had the screen cropped down a little bit, so you couldn't go the full screen width like we would try to do in Wolfenstein. But I learned a lot. I got the floors and ceilings and lightings, and it looked great. They were great artists up there, and it was an inspiration for us to look at some of that stuff. But I had learned enough from that I had the plan for, I knew faster ways to do the lighting and shadowing, and I wanted to do this freeform geometry. I wanted to break out of this tile-based 90-degree world limitations. So we had, that was when we got our next stations, and we were working with these higher-powered systems, and we built an editor that let us draw kind of arbitrary line segments, and I was working hard to try to make something that could render this fast enough. I was pushing myself pretty hard, and we were at a point where we could see some things that looked amazingly cool, but it wasn't really fast enough for the way I was doing it. For this flexibility, it was no longer, I couldn't just raycast into it, and I had these very complex sets of lines, and simple little worlds were okay, but the cool things that we wanted to do just weren't quite fast enough. And I wound up taking a break at that point, and I did I did 2 ports of our games, Wolfenstein to the Super Nintendo. It was a crazy difficult thing to do, which was an even slower processor. It was like a couple megahertz processor. And it had been this whole thing where we had farmed out the work, and it wasn't going well, and I took it back over, and trying to make it go fast on there where it really did not have much processing power. The pixels were stretched up hugely, and it was pretty ugly when you looked at it, but in the end, it did come out fast enough to play and still be kind of fun from that. But that was where I started using BSP trees, or binary space partitioning trees. It was one of those things, I had to make it faster there. It was a stepping stone where it was reasonably easy to understand in the grid world of Wolfenstein, where it was all still 90-degree angles. BSP trees I eased myself into it with that. and it was a big success. Then when I came back to working on Doom, I had this new tool in my toolbox. It was going to be a lot harder with the arbitrary angles of Doom. This was where I really started grappling with epsilon problems, and just, up until that point, I hadn't really had to deal with the fact that so many numeric things. This almost felt like a betrayal to me, where people had told me that I had mathematicians up on a bit of a pedestal, where people think I'm a math wizard, and I'm not. Everything that I did was really done with a solid high school math understanding. Algebra 2, trigonometry, and that was what got me all the way through Doom and Quake and all of that, of just understanding basics of matrices and knowing it well enough to do something with it.
What's the epsilon problems you ran into?
So when you wind up taking a sloped line and you say, I'm going to intersect it with another sloped line, then you wind up with something that's not going to be on these nice grid boundaries. With the Wolfenstein tile maps, all you've got is horizontal and vertical lines looking at it from above, and if you cut one of them, it's just obvious the other one gets cut exactly at that point. But when you have angled lines, you're doing a kind of a slope intercept problem, and you wind up with rational numbers there, where things that are not going to evenly land on an integer or even on any fixed point value that you've got. So everything winds up having to snap to some fixed point value, so the lines slightly change their angle. You wind up, if you cut something here, this one's going to bend a little this way, and it's not going to be completely straight. And then you come down to all these questions of, well, this one is a point on an angled line. You can't answer that in finite precision unless you're doing something with actual rational numbers. And later on, I did waste far too much time chasing things like that. How do you do precise arithmetic with rational numbers? And it always blows up eventually, exponentially as you do it up.
So these kind of things are impossible with computers. So
they're possible. Again, there are paths to doing it, but you can't fit them conveniently in any of the numbers. You need to start using big nums and different factor trackings of different things.
So you have to, if you have any elements of OCD and you want to do something perfectly, you're screwed if you're working with floating point.
Yeah.
So you had to deal with this for the first time.
And there were lots of challenges there about, like, okay, they build this cool thing, and the way the BSP trees work is it basically takes the walls and it carves other walls by those walls in this clever way that you can then take all of these fragments, and then you can for sure from any given point get an ordering of everything in the world, and you can say this goes in front of this, goes in front of this, all the way back to the last thing. And that's super valuable for graphics, where kind of a classic graphics algorithm would be Painter's algorithm. You paint the furthest thing first, and then the next thing, and then the next thing, and then it comes up and it's all perfect for you. That's slow because you don't want to have drawn everything like that, but you can also flip it around and draw the closest thing to you. And then if you're clever about it, you can figure out what you need to draw that's visible beyond that.
And that's what BSP trees allow you to do.
Yeah, so it's combined with a bunch of other things, but it gives you that ordering. It's a clever way of doing things. And I remember I had learned this from one of my graphics Bible at the time, a book called Foley and Van Dam. And again, it was a different world back there. There was a small integer number of books. And this book, this book that was a big fat college textbook that I had read through many times. I didn't understand everything in it. Some of it wasn't useful to me, but they had the little thing about finite orderings of you draw a little T-shaped thing, and you can say you can make a fixed ahead of time order from this, and you can generalize this with the DSP trees. And I got a little bit more information about that. And it was kind of fun later while I was working on Quake. I got to meet Bruce Naylor, who was one of the original researchers that developed those technologies, for academic literature. And that was kind of fun. But I was very much just finding a tool that could help me solve what I was doing. And I was using it in this very crude way in a two-dimensional fashion rather than the general 3D. The epsilon problems got much worse in Quake in 3 dimensionals when things angle in every way. But eventually I did sort out how to do it reliably on Doom. There were still a few edge cases in Doom that were not absolutely perfect, where they even got terminologies in the communities, like when you got to something where it was messed up, it was a Hall of Mirrors effect, because you'd sweep by and it wouldn't draw something there, and you would just wind up with the leftover remnants as you flipped between the two pages. But BSP trees were important for it, but it's again worth noting that after we did Doom, our major competition came from Ken Silverman and his build engine, which was used for Duke Nukem 3D and some of the other games for 3D Realms. And he used a completely different technology, nothing to do with BSP trees. So there's not just a one true way of doing things. There were critical things about, to make any of those games fast, you had to separate your drawing into, you drew vertical lines and you drew horizontal lines, just kind of changing exactly what you would draw with them. That was critical for the technologies at that time, and like all the games that were kind of like that wound up doing something similar. But there were still a bunch of other decisions that could be made, and we made good enough decisions on everything on Doom. We brought in multiplayer significantly, and it was our first game that was designed to be modified by the user community, where we had this whole setup of our WAD files and PWADs and things that people could could build with tools that we released to them, and they eventually rewrote to be better than what we released. But they could build things, and you could add it to your game without destructively modifying it, which is what you had to do in all the early games. You literally hacked the data files or the executable before, while Doom was set up in this flexible way so that you could just say, run the normal game with this added on top, and it would overlay just the things that you wanted to there.
Would you say that Doom was kind of the first true 3D game that you created?
So no, it's still, Doom would usually be called a 2.5D game, where it had three-dimensional points on it, and this is another one of these kind of pedantic things that people love to argue about what was the first 3D game. I still, like every month probably I hear from somebody about, well, was Doom really a 3D game or something? And I give the point where characters had 3 coordinates. So you had like an X, Y, and Z. The Cacodemon could be coming in very high and come down towards you. The walls had 3 coordinates on them, so in some sense it's a 3D game engine, but it was not a fully general 3D game engine. You could not build a pyramid in Doom because you couldn't make a sloped wall, which was slightly different. Where in that previous Shadowcaster game, I could have vertexes and have a sloped floor there, but changes that I made for Doom to get higher speed and a different set of flexibility traded away that ability. But you literally couldn't make that. You could not. You could make different heights of passages, but you could not make a bridge over another area. You could not go over and above it. So it still had some 2D limitations to it.
That's more about the building versus the actual experience, because the experience
is... It felt like things would come at you, but again, you couldn't look up either. You could only pitch. It was 4 degrees of freedom rather than 6 degrees of freedom. You did not have the ability to tilt your head this way or pitch up and down.
So that takes us to Quake. What was the leap there? What were some fascinating technical challenges, and there were a lot, or not challenges, but innovations that you've come up with?
So Quake was kind of the first thing where I did have to kind of come face to face with my limitations, where it was the first thing where I really did kind of give it my all and still come up a little bit short in terms of what and when I wanted to get it done. And the company had some serious stresses through the whole project, and we bit off a lot. So the things that we set out to do was, it was going to be really a true 3D engine where it could do 6 degrees of freedom. You could have all the viewpoints. You could model anything. It had a really remarkable new lighting model with the surface caching and things. That was one of those where it was starting to do some things that they weren't doing even on the very high-end systems. And it was going to be completely programmable in the modding standpoint, where the thing that you couldn't do in Doom, you could replace almost all of the media, but you couldn't really change the game. There were still some people that were doing the hex editing of the executable, the dehacked things where you could change a few things about rules, and people made some early capture the flag type things by hacking the executable, but it wasn't really set out to do that. Quake was going to have its own programming language that the game was going to be implemented in it, and that would be able to be overwritten just like any of the media. Code was going to be data for that, and you would be able to have expansion packs that changed fundamental things and mods and so on. And the multiplayer was going to be playable over the internet. It was going to support client-server rather than peer-to-peer. So we had the possibility of supporting larger numbers of players in disparate locations with this full flexibility of the programming overrides, with full 6 degrees of freedom, modeling and viewing, and with this fancy new light-mapped kind of surface caching side. It was a lot, and this was one of those things that if I could go back and tell younger me to do something differently, it would have been to split those innovations up into 2 phases, in 2 separate games.
What would be phase 1 and phase 2?
So it probably would have been taking the Doom rendering engine and bringing in the TCP/IP client server,
focusing on the multiplayer,
and the Quake C, or would have been Doom C programming language there. So I would have split that into programming language and networking with the same Doom engine, rather than forcing everybody to go towards the Quake engine, which really meant getting a Pentium. While it ran on a 486, it was not a great experience there. We could have made more people happier and gotten 2 games done in 50% more time.
So speaking of people happier, our mutual friend Joe Rogan, it seems like the most important moment of his life is centered around Quake. So it was a definitive part of his life. So would he agree with your thinking that they should split? So he, as a person who loves Quake and played Quake a lot, would he agree that you should have done the Doom engine and focus on the multiplayer for phase 1? Or in your looking back, is the 3D world that Quake created was also fundamental to the enriching experience?
I would say that what would have happened is you would have had a Doom-looking but Quake-feeling game 8 months earlier, and then maybe 6 months after Quake actually shipped, then there would have been the full running on a Pentium 6 Degree of Freedom graphics engine type things there. So it's not that it wouldn't have been there. It would have been something amazingly cool earlier, and then something even cooler somewhat later, where I would much rather have gone and done 2 one-year development efforts, cycle them through, be a little more pragmatic about that, rather than killing us ourselves on the whole Quake development. But I say it's obviously things worked out well in the end, but looking back and saying, how would I optimize and do things differently, that did seem to be a clear case where going ahead, and we had enormous momentum on Doom. We did Doom 2 as the kind of commercial box version after our shareware success with the original, but we could have just made another Doom game adding those new features in. It would have been huge. We would have learned all the same lessons, but faster, and it would have given 6 Degree of Freedom and Pentium class systems a little bit more time to get mainstream, because we did cut out a lot of people with the hardware requirements for Quake.
Was there any dark moments for you personally, psychologically, in having such harsh deadlines and having to also meet difficult technical challenges?
So I've never really had really dark black places. I mean, I can't necessarily put myself in anyone else's shoes, but I understand a lot of people have significant challenges with their mental health and well-being, and I've been super stressed. I've been unhappy as a teenager in various ways, but I've never really gone to a very dark place. I just seem to be largely immune to what really wrecks me. I mean, I've had plenty of time when I'm very unhappy and miserable about something, but it's never hit me like I believe it winds up hitting some other people. I've borne up well under whatever stresses have kind of fallen on me, and I've always coped best on that when all I need to do is usually just kind of bear down on my work. I pull myself out of whatever hole I might be slipping into by actually making progress. I mean, maybe if I was in a position where I was never able to make that progress, I could have slid down further, but I've always been in a place where, okay, a little bit more work, maybe I'm in a tough spot here, but I always know if I just keep pushing, eventually I break through and I make progress, I feel good about what I'm doing. And that's been enough for me so far in my life.
Have you seen it in the distance? Ideas of depression or contemplating suicide? Have you seen those things far?
So it was interesting when I was a teenager. I was was probably at some level a troubled youth. I was unhappy most of my teenage years. I wanted to be on my own doing programming all the time. As soon as I was 18, 19, even though I was poor, I was doing exactly what I wanted, and I was very happy. But high school was not a great time for me, and I had a conversation with the school counselor, and they're kind of running their script. It's like, okay, it's kind of a weird kid here. Let's carefully probe around. It's like, do you ever think about ending it all? I'm like, no, of course not. Never, not at all. This is temporary. Things are going to be better. And that's always been kind of the case for me. And obviously, that's not that way for everyone. And other people do react differently. And
what was your escape from the troubled youth? Music, video games, books. How did you escape from a world that's full of cruelty and suffering and this?
Yeah, I mean, I was not a victim of cruelty and suffering. It's like I was an unhappy, somewhat petulant youth, in my point where I'm not putting myself up with anybody else's suffering, but I was unhappy objectively. And the things that I did that very much characterized my childhood were I had books, comic books, Dungeons and Dragons, arcade games, video games. Like some of my fondest childhood memories are the convenience stores, the 7-Elevens and Quick Trips, because they had a spinner rack of comic books and they had a little side room with 2 or 3 video games, arcade games in it. And that was very much my happy place. If I get my comic books, and if I could go to a library and go through the little 000 section where computer books were supposed to be, and there were a few sad little books there, but still just being able to sit down and go through that. And I read a ridiculous number of books, both fiction and nonfiction, as a teenager. And my rebelling in high school was just sitting there with my nose in a book, ignored in the class. And teachers had a range of reactions to that. Some more accepting of it than others.
I'm with you on that. So let us return to Quake for a bit with the technical challenges. What everything together from the networking to the graphics. What are some things you remember that were innovations you had to come up with in order to make it all happen?
Yeah, so there were a bunch of things on Quake where, on the one hand, the idea that I built my own programming language to implement the game in, looking back, and I try to tell people, it's like every high-level programmer sometime in their career goes through and they invent their own language. It just seems to be a thing that's pretty broadly done. People will be like, I'm going to go write a computer programming language. And I don't regret having done it, but after that, I switched from Quake C, my quirky little pseudo object-oriented, entity-oriented language there. Quake 2 went back to using DLLs with C, and then Quake 3, I implemented my own C interpreter or compiler, which was a much smarter thing to do that I should have done originally for Quake. But building my own language was an experience. I learned a lot from that. And then there was a generation of game programmers that learned programming with Quake C, which I feel kind of bad about because we give JavaScript a lot of crap, but Quake C was nothing to write home about there. But it allowed people to do magical things. You get into programming not because you love the BNF syntax of a language. It's because the language lets you do something that you cared about.
And here is very much you could do something in a whole beautiful three-dimensional world.
And the idea and the fact that the code for the game was out there, you could say, I like the shotgun, but I want it to be more badass. You go in there and say, okay, now it does 200 points damage. And then you go around with a big grin on your face, blowing up monsters all over the game. So yeah, it's it is not what I would do today going back with that language, but that was a big part of it. Learning about the networking stuff, because it's interesting where I learned these things by reading books. So I would get a book on networking, find something, I read all about it and learn, okay, packets, they can be, out of order, lost, or duplicated. These are all the things that can theoretically happen to packets. So I wind up spending all this time thinking about how do you feel about all of that. And it turns out, of course, in the real world, those are things that, yes, theoretically can happen with multiple routes, but they really aren't things that your 99.999% of your packets have to deal with. So there was learning experiences about lots of that, like when TCP is appropriate versus UDP, and how if you do things in UDP, you wind up reinventing TCP badly in almost all cases. So there's good arguments for using both for different game technology, different parts of the game process, transitioning from level to level and all. But the graphics were the showcase of what Quake was all about. It was this graphics technology that nobody had seen there. And it was a while before there were competitive things out there. And it went a long time internally really not working, where we were even building levels where the game just was not at all shippable. There was large fractions of the world disappearing, not being there, or being really slow in various parts of it. And it was this act of faith. It's like, I think I'm going to be able to fix this. I think I'm going to be able to make this work. And lots of stuff changed where the level designers would build something and then have to throw it away as something fundamental in the kind of graphics or level technology changed. And so there were two big things that contributed to making it possible at that time frame. Two new things. There was certainly hardcore optimized low-level assembly language. This was where I had hired Michael Abrash away from Microsoft. And he had been one of my early inspirations where back in the soft disk days, the library of magazines that they had, some of my most treasured ones were Michael Abrash's articles in Dr. Dobbs' Journal. And it was amazing after all of our success in Doom, we were able to kind of hit him up and say, hey, we'd like you to come work at id Software. And he was in this senior technical role at Microsoft. And and he was on track for it. And this was right when Microsoft was starting to take off. And I did eventually, convince him that what we were doing was going to be really amazing with Quake. It was going to be something nobody had seen before. It had these aspects of what we were talking about. We had metaverse talk back then. We had read Snow Crash, and we knew about this. And Michael was big into the science fiction, and we would talk about all that and kind of spin this tale. And it was some of the same conversations that we have today about the metaverse, about how you could have different areas linked together by portals, and you could have user-generated content and changing out all of these things.
So you really were creating the metaverse with Quake.
And we talked about things like Doom used to be advertised as a virtual reality experience. That was the first wave of virtual reality was in the late 80s and early 90s. You had like the Lawnmower Man movie, and you had Time and Newsweek talking about the early VPL headsets. And of course, that cratered so hard that people didn't want to look at virtual reality for decades after that, where it was smoke and mirrors. It was not real in the sense that you could actually do something real and valuable with it. But still, we had that kind of common set of talking points. And we were talking about what these games could become and how you'd like to see people building all of these creative things. Because we were seeing an explosion of work with Doom at that time, where people were doing amazingly cool things. Like we saw cooler levels that we had built coming out of the user community, and then people finding ways to change the characters in different ways, and it was great. And we knew what we were doing in Quake was removing those last things. There was some quirky things with a couple of the data types that didn't work right for overriding, and then the core thing about the programming model. and I was definitely going to hit all of those in Quake. But the graphics side of it was, it was still, I knew what I wanted to do, and it was one of these hubris things where it's like, well, so far I've been able to kind of kick everything that I set out to go do. But Quake was definitely a little bit more than could be comfortably chewed at that point. And but Michael was one of the strongest programmers and graphics programmers that I knew. And he was one of the people that I trusted to write assembly code better than I could. And there's a few people that I can point to about things like this where I'm a world-class optimizer. I mean, I make things go fast, but I recognize there's a number of people that can write tighter assembly code, tighter SIMD code, or tighter CUDA code than I can write. My best strengths are a little bit more at the system level. I mean, I'm good at all of that, but the most leverage comes from making the decisions that are a little bit higher up, where you figure out how to change your large-scale problems so that these lower-level problems are easier to do, or it makes it possible to do them in a uniquely fast way. So most of my my big wins in a lot of ways, from all the way from the early games through VR and the aerospace work that I'm doing and hopefully the AI work that I'm working on now, is finding an angle on something that means you trade off something that you maybe think you need, but it turns out you don't need it, and by making a sacrifice in one place, you can get big advantages in another place.
Is it clear at which level of the system those big advantages can be gained?
It's not always clear, and that's why the thing that I try to make one of my core values, and I proselytize to a lot of people, is trying to know the entire stack, trying to see through everything that happens. And it's almost impossible on like the web browser level of things, where there's so many levels to it, but you should at least understand what they all are, even if you can't understand all the performance characteristics at each level. But it goes all the way down to literally the hardware. So what is this chip capable of? What is this software that you're writing capable of, and then what is architecture you put on top of that, the ecosystem around it, all the people that are working on it. So there are all these decisions, and they're never made in a globally optimal way, but sometimes you can drive a thread of global optimality through it. You can't look at everything, it's too complicated, but sometimes you can step back up and make a different decision. We kind of went through this on the graphics side on Quake, where in some ways it was kind of bad, where Michael would spend his time writing, like I'd rough out the basic APIs, like, okay, here's our span rasterizer, and he would spend a month writing this, beautiful cycle-optimized piece of assembly language that does what I asked it to do, and he did it faster than my original code would do, or probably what I would be able to do even if I had spent that month on it. But then we'd have some cases when I'd be like, okay, well, I figured out at this higher level, instead of drawing these in painter's order here, I do a span buffer, and it cuts out 30% or 40% all of these pixels, but it means you need to rewrite kind of this interface and all of that. And I felt that wore on him a little bit, but in the end it was the right thing to do, where we wound up changing that rasterization approach, and we wound up with a super optimized assembly language core loop, and then a good system around it, which minimized how much that had to be called.
And so in order to be able to do this kind of system level thinking, whether we're talking about game development, aerospace, nuclear energy, AI, VR, you have to be able to understand the hardware, the low-level software, the high-level software, the design decisions, the whole thing, the full stack of it.
Yeah, and that's where a lot of these things become possible. When you're bringing the future forward, I mean, there's a pace that everything just kind of glides towards, where we have a lot of progress that's happening at so many different ways. You kind of slide towards progress just left to your own. Programs just get faster. For a while, it wasn't clear if they were going to get fatter quicker than they get faster, and it cancels out. But it is clear now in retrospect. No, programs just get faster and have gotten faster for a long time. But if you want to do something like back at that original talking about scrolling games, say, what, this needs to be 5 times faster. Well, we can wait 6 years and it'll naturally get that much faster at that time. Or you come up with some really clever way of doing it. So there are those opportunities like that in a whole bunch of different areas. Now, most programmers don't need to be thinking about that. There's not that many, there's a lot of opportunities for this, but it's not everyone's workaday type stuff. So everyone doesn't have to know how all these things work. They don't have to know how their compiler works, how the processor chip manages cache eviction, and all these low-level things. But sometimes there are powerful opportunities that you can look at and say, we can bring the future 5 years faster. We can do something that, wouldn't it be great if we could do this? Well, we can do it today if we make a certain set of decisions. It is, in some ways, smoke and mirrors, where you say it's like Doom was a lot of smoke and mirrors, where people thought it was more capable than it actually was, but we picked the right smoke and mirrors to deploy in the game, where by doing this, people will think that it's more general, we are going to amaze them with what they've got here, and they won't notice that it doesn't do these other things. So smart decision making at that point, that's where that kind of global, holistic, top-down view can work. And I'm really a strong believer that technology should be sitting at that table having those discussions, because you do have cases where you say, well, you want to be the Jonathan Ivey or whatever, where it's a pure design solution. And that's, in some cases now, where you truly have almost infinite resources. Like, if you're trying to do a scrolling game on the PC now, you don't even have to talk to a technology person. You can just have, any intern can make that go run as fast as it needs to be there, and it can be completely design-based. But if you're trying to do something that's hard, either that can't be done for resources like VR on a mobile chipset, or that we don't even know how to do yet, like artificial general intelligence, it's probably going to be a matter of coming at it from an angle. I mean, for AGI, we have some of the Hutter principles about how you can there are theoretical ways that you can say this is the optimal learning algorithm that can solve everything, but it's completely impractical. You just can't do that. So clearly, you have to make some concessions for general intelligence, and nobody knows what the right ones are yet. So people are taking different angles of attack. I hope I've got something clever to come up with in that space.
It's been surprising to me, and I think perhaps it is a principle of progress, that smoke and mirrors somehow is the way you build the future. You kind of fake it till you make it, and you almost always make it. And I think that's going to be the way we achieve AGI. That's going to be the way we build consciousness into our machines. There's philosophers debate about the Turing test is essentially about faking it till you make it. You start by faking it, and I think that always leads to making it. Because if we look at history,
arguments, but as soon as people start talking about qualia and consciousness and Chinese rooms and things, it's like, I just check out. I just don't think there's any value in those conversations. It's just like, go ahead, tell me it's not going to work. I'm going to do my best to try to move it.
I don't know if you want to say they sure as heck make you feel like they're conscious in a certain way that's not here today, but is you can see the kernel, like the flame, the beginnings of a flame.
We don't have line of sight. There's glimmerings of light in the distance for all of these.
Yeah, I'm hearing murmuring in a distant room. Well, let me ask you a human question here. You've in the game design stage, you've done a lot of incredible work throughout, but in terms of game design, you have changed the world. And the few people around you do the same. Famously, there's some animosity. There's much love, but there's some animosity between you and John Romero. What is at the core of that animosity and human tension?
So there really hasn't been, for a long time, even at the beginning, like, yes, I did push Romero out of the company. And this is one of the things that I look back, if I could go back telling my younger self some advice about things, the original founding kind of corporate structure at id Software really led to a bunch of problems. We started off with us as equal partners, and we had a buy-sell agreement because we didn't want outsiders to be telling us what to do inside the company. And that did lead to a bunch of the problems where I was sitting here going, it's like, all right, I'm working harder than anyone. I'm doing these technologies, nobody's done before, but we're all equal partners. And then I see, somebody that's not working as hard, and I can't say I was the most mature about that. I was 20-something years old, and it did bother me when I'm like, everybody, okay, we need to all pull together, and we've done it before. Everybody, we know we can do this if we get together and we grind it all out. But not everybody wanted to do that for all time. And I was the youngest one of the crowd there. I had different sets of kind of backgrounds and motivations, and left at that point where it was, all right, either everybody has to be contributing like up to this level, or they need to get pushed out. That was not a great situation. And I look back on it, and no, we pushed people out of the company that could have contributed if there was a different framework for them. And the modern kind of Silicon Valley, like, let your stock vest over a time period, and maybe it's non-voting stock and all those different things. We knew nothing about any of that. I mean, we didn't know what we were doing in terms of corporate structure or anything.
So if you think the framework was different, some of the human tension could have been a little bit.
It almost certainly would have. I mean, I look back at that, and it's like, even trying to sum it up in my mind, it's like, I know I was really, really angry about, like Romero not working as hard as I wanted him to work, or not carrying his load on the design for Quake and coming up with things there. But, he was definitely doing things. He made some of the best levels there. He was working with some of our external teams like Raven on the licensing side of things. But, but there were differences of opinion about it. But he landed, right on his feet. He got $20 million from IDOS to go do Ion Storm, and he got to do things his way and spun up 3 teams simultaneously, because that was always one of the challenging things in id, where we were doing these single string, one project after another. And I think some of them wanted to grow the company more. I didn't, because I knew people that were saying that, oh, companies turn to shit when you got 50 employees. It's just a different world there. And I loved our little dozen people working on the projects. But you can look at it and say, well, business realities matter. It's like you're super successful here, and we could take a swing and a miss on something, but do it a couple times and you're out of luck. There's a reason companies try to have multiple teams running at one time. And so that was, again, something I didn't really appreciate back then.
So if you look past all that, you did create some amazing things together. What did you love about John Romero? What did you respect and appreciate about him? What did you admire about him? What did you learn from him?
When I met him, he was the coolest programmer I'd ever met. He had done all of this stuff. He had made all of these games. He had worked at one of the companies that I thought was the coolest at Origin Systems, and he knew all this stuff. He made things happen fast, and he was also kind of a polymath about this, where he made his own. He drew his own art. He made his own levels, as well as he worked on sound design systems on top of actually being a really good programmer. And we went through it was kind of fun, where one of the early things that we did, where there was kind of the young buck bit going in, where I was the new guy, and he was the top man programmer at the soft disk area. And eventually we had sort of a challenge over the weekend that we were going to race to implement this game, to port one of our PC games back down to the Apple II. And that was where we finally kind of became clear. It's like, okay, Carmack stands a little bit apart on the programming side of things. And, but Romero then very gracefully moved into, well, he'll work on the tools, he'll work on the systems, do some of the game design stuff, as well as contributing on, starting to lead the design aspects of a lot of things. So he was enormously valuable in the early stuff, and so much of Doom and even Quake have his stamp on it in a lot of ways. But he wasn't at the same level of focus that I brought to the work that we were doing there. And he really did. We hit such a degree of success that it was all in the press about that. The Rockstar game programmers.
Yeah. And, it's the Beatles problem.
Yeah. I mean, and he ate it up, and he did personify. There was the whole game developers with, with Ferraris that, that we had there. And I thought that, that led to some challenges there. But so much of the stuff that was great in the games did come from him, and I would certainly not take that away from him. And even after we parted ways, and he took his swing with IDOS, in some ways he was ahead of the curve with mobile gaming as well, where one of his companies after IDOS was working on feature phone game development, and I wound up doing some of that just before the iPhone, crossing over into the iPhone phase there. And that was something that clearly did turn out to be a huge thing, although he was too early for what he was working on at that time. We've had pretty cordial relationships, where I was happy to talk with him anytime I'd run into him at a conference. I have actually had some other people just say, it's like, oh, you shouldn't go over there and give him the time of day, or felt that Masters of Doom was played things up in a way that I shouldn't be too happy with. But I'm okay with all of that. And
so you still got love in your heart.
Yeah, I mean, I just talked with him last year, or I guess it was even this year, about mentioning that I'm going off doing this AI stuff. I'm going big into artificial intelligence, and he had a bunch of ideas for how AI is going to play into gaming, and asked if I was interested in collaborating. And it's not in line with what I'm doing, but I do. I wish almost everyone the best. I mean, I know I may not have parted on the best of terms with with some people, but I was thrilled to see Tom Hall writing VR games now. He wrote working on a game called Demio, which is really an awesome VR game. It's like Dungeons and Dragons. We all used to play Dungeons and Dragons together. That was one of the things. That was what we did on Sundays in the early days. I would Dungeon Master, and they'd all play. And so it really made me smile seeing Tom involved with an RPG game in virtual reality.
You were the CTO of Oculus VR since 2013, and maybe lessen your involvement a bit in 2019. Oculus was acquired by Facebook, now Meta, in 2014. You've spoken brilliantly about both the low-level details, the experimental design, and the big picture vision of virtual reality. Let me ask you about the metaverse, the big question here, both philosophically and technically. How hard is it to build the metaverse? What is the metaverse, in your view? You started with discussing and thinking about Quake as a kind of metaverse. As you think about it today, what is the metaverse? The thing that could create this compelling user value, this experience that will change the world, and how hard is it to build it?
So the term comes from Neil Stephenson's book Snow Crash, which many of us had read back in the 90s. It was one of those kind of formative books. And there was this sense that the possibilities and kind of the freedom and unlimited capabilities to build a virtual world that does whatever you want, whatever you ask of it, has been a powerful draw for generations of developers, game developers specifically, and people that are thinking about more general purpose applications. So we were talking about that back in the Doom and Quake days, about how do you wind up with an interconnected set of worlds that you kind of visit from one to another. And as web pages were becoming a thing, you start thinking about what is the interactive kind of 3D based equivalent of this. And there were a lot of really bad takes. You had Vermal, and virtual reality markup languages, and there's aspects like that came from people saying, well, what kind of capabilities should we develop to enable this? And that kind of capability first work has usually not panned out very well. On the other hand, we have successful games that started with things like Doom and Quake and communities that formed around those, and whether it was server lists in the early days or literal portaling between different games, and then modern things that are on completely different order of magnitude, like Minecraft and Fortnite, that have 100 million plus users. I still think that that's the right way to go to build the metaverse, is you build something that's amazing that people love and people wind up spending all their time in because it's awesome, and you expand the capabilities of that.
So
now,
even if it's a very basic experience,
as long as people,
awesome,
Minecraft is an amazing case study in so many things, where what's been able to be done with that is really enlightening. And there are other cases where, like right now, Roblox is basically a game construction kit aimed at kids. And that was a capability first play, and it's achieving scale that's on the same order of those things. So it's not impossible, but my preferred bet would be you make something amazing that people love and you make it better and better. And that's where I could say we could have gone back and followed a path kind of like that in the early days. If you just kind of take the same game, whether it's when Activision demonstrated that you could make Call of Duty every year, and not only is it not bad, people kind of love it, and it's very profitable. The idea that you could have taken something like that, take a great game, release a new version every year that lets the capabilities grow and expand, to start saying it's like, okay, it's a game about running around and shooting things, but now you can have bring your media into it. You can add persistence of social signs of life, or whatever you want to add to it. I still think that's quite a good position to take. And I think that while Meta is doing a bottoms-up capability approach with Horizon Worlds, where it's a fairly general purpose, creators can build whatever they want in their sort of thing, it's hard to compare and compete with something like Fortnite, which also has enormous amounts of creativity, even though it was not designed originally as a general purpose sort of thing. So we have examples on both sides. Me personally, I would have bet on trying to do entertainment, valuable destination first, and expanding from there.
So can you imagine the thing that will be kind of, if we look back a couple of centuries from now and you think about the experiences that marked the singularity, the transition in where most of our world moved into virtual reality, what do you think those experiences will look like?
So I do think it's going to be kind of like the way the web slowly took over, where you're the frog in the pot of water that's slowly heating up, where having lived through all of that, I remember when it was shocking to start seeing the first website address on a billboard, when you're like, hey, my computer world is infecting the real world. This is spreading out in some way. But there's still, when you look back and say, well, what made the web take off? And it wasn't a big bang sort of moment there. It was a bunch of little things that turned out not to even be the things that are relevant now that brought them into it. So
well, I wonder if like you said, you're not a historian. So maybe there's a historian out there that could really identify that moment, data-driven way. It could be like MySpace or something like that. Maybe the first major social network that really reached into non-geek world or something like that.
I think that's kind of the fallacy of historians, though, looking for some of those kind of primary dominant causes, where so many of these things are, like, we see an exponential curve, but it's not because like one thing is going exponential. It's because we have hundreds of little sigmoid curves overlapped on top of each other, and they just happen to keep adding up so that you've got something kind of going exponential at any given point, but no single one of them was the critical thing. There were dozens and dozens of things. And you're seeing the transitions of stuff, like as obviously MySpace giving way to other things, but even like blogging giving way to social media and getting resurrected in other guises, and
then memes
things
with
that
the
happened there.
Dancing baby gif or whatever, the all you base now belong to us, whatever those early memes that led to the modern memes, and the humor on the different evolution of humor on the internet. And I'm sure the historians will also write books about from the different websites that create the infrastructure for that humor, like Reddit and all that kind of stuff.
So people will go back and they will name firsts and critical moments, but it's probably going to be a poor approximation of what actually happens. And we've already seen, like in the VR space, where it didn't play out the way we thought it would in terms of what was going to be. Like the modern era of VR basically started with my E3 demo of Doom 3 on the Rift prototype. So we're like, first-person shooters in VR, match made in heaven, right? And that didn't work out that way at all. They have the most comfort problems with it, and then the most popular virtual reality app is Beat Saber, which nobody predicted back then.
What's that make you, like, from first principles, if you were to, like, reverse engineer that? Why are these like silly fun games
well,
the most?
It actually makes very clear sense when you analyze it from hindsight and look at the engineering reasons, where it's not just that it was a magical, quirky idea. It was something that played almost perfectly to what turned out to be the real strengths of VR, where the one thing that I really underestimated importance in VR was the importance of the controllers. I was still thinking we could do a lot more with the gamepad, and just the amazingness of taking any existing game, being able to move your head around and look around. That was really amazing. But the controllers were super important. But the problem is, so many things that you do with the controllers just suck. It feels like it breaks the illusion. Like trying to pick up glasses with the controllers, where you're like, oh, use the grip button when you're kind of close and it'll snap into your hand. All of those things are unnatural actions that you do them and it's still part of the VR experience. But Beat Saber winds up playing only to the strengths. It completely hides all the weaknesses of it, because you are holding something in your hand, you keep a solid grip on it the whole time. It slices through things without ever bumping into things. You never get into the point where, I'm knocking on this table, but in VR, my hand just goes right through it. So you've got something that slices through, so it's never your brain telling you, oh, I should have hit something. You've got a lightsaber here. It's just you expect it to slice through everything. Audio and music turned out to be a really powerful aspect of virtual reality, where you're blocking the world off and constructing the world around you. And being something that can run efficiently on even this relatively low-powered hardware and can have a valuable loop in a small amount of time, where a lot of modern games, you're supposed to sit down and play it for an hour just to get anywhere. Sometimes a new game takes an hour to get through the tutorial level, and that's not good for VR for a couple reasons. You do still have the comfort issues if you're moving around at all, but you've also got just discomfort from the headset, battery lifespan on the mobile versions. So having things that do break down into 3 and 4 minute windows of play, that turns out to be very valuable from a gameplay standpoint. So it winds up being kind of a perfect storm of all of these things that are really good. It doesn't have any of the comfort problems. You're not navigating around. You're standing still. All the stuff flies at you. It has placed audio strengths. It adds the whole fitness in VR. Nobody was thinking about that back at the beginning, and it turns out that is an excellent daily fitness thing to be doing. If you go play an hour of Beat Saber or Supernatural or something, that is legit solid exercise, and it's more fun than doing it just about any other way there.
So that's kind of the arcade stage of things. If I were to say, with my experience with VR, the thing that I think is powerful is maybe it's not here yet, but the degree to which it is immersive in the way that Quake is immersive. It takes you to another world. For me, because I'm a fan of role-playing games, the Elder Scrolls series, like Skyrim or even Daggerfall, it just takes you to another world. And when you're not in that world, you miss not being there. And then you kind of want to stay there forever, because life is shitty.
Look, the whole point
and you just want to go to
VR
this place.
Is that there was a time when we were kind of asked to come up with, like, what's your view about VR? And my pitch was that it should be better inside the headset than outside. It's the world as you want it.
Yeah.
And everybody thought that was dystopian, and like that's like, oh, you're just going to forget about the world outside. And I don't get that mindset, where the idea that if you can make the world better inside the headset than outside, you've just improved the person's life that has a headset that can wear it. And there are plenty of things that we just can't do for everyone in the real world. Everybody can't have Richard Branson's private island, but everyone can have a private VR island and have the things that they want on it. And there's a lot of these kind of rivalrous goods in the real world that VR can just be better at. We can do a lot of things like that can be very, very rich. So yeah, I think it's going to be a positive thing, this world where people want to go back into their headset, where it can be better than somebody that's living in a tiny apartment can have a palatial estate in virtual reality. They can have all their friends from all over the world come over and visit them without everybody getting on a plane and meeting in some place and dealing with all the other logistics hassles. There is real value in the presence that you can get for remote meetings. It's all the little things that we need to sort out, but those are things that we have line of sight on. People, that have been in like a good VR meeting using workrooms where you can say, oh, that was better than a Zoom meeting. But of course, it's more of a hassle to get into it. Not everyone has a headset. Interoperability is worse. You cap out at a certain number. There's all these things that need to be fixed, but that's one of those things you can look at and say, we know there's value there. We just need to really grind hard to file off all the rough edges and make that possible.
So you do think we have line of sight? Because there's a reason, like, I do this podcast in person, for example. Doing it remotely, it's not the same. And if somebody asked me why it's not the same, I wouldn't be able to write down exactly why. But you're saying that it's possible, whatever the magic is of in-person interaction, that immersiveness of the experience, we are almost there.
So the idea of like doing a VR interview with someone, I'm not saying it's here right now, but you can see glimmers of what it should be, and we largely know what would need to be fixed and improved to, like you say, there's a difference between a remote interview, doing a podcast over Zoom or something, and face-to-face. There's that sense of presence, that immediacy, the super low latency responsiveness, being able to see all the subtle things there, occupying the same field of view. And all of those are things that we absolutely can do in VR. And that simple case of a small meeting with a couple people, that's the much easier case than everybody thinks the Ready Player One multiverse with 1,000 people going across a huge bridge to amazing places. That's harder in a lot of other technical ways. Not to say we can't also do that, but that's further away and has more challenges. But this small thing about being able to have a meeting with one or a few people and have it feel real, feel like you're there. If you have the same interactions and talking with them, you get subtle cues. As we start getting eye and face tracking and some of the other things on high-end headsets, a lot of that is going to come over. And it doesn't have to be as good. This is an important thing that people miss, where there was a lot of people that, especially rich people, that would look at VR and say, it's like, oh, this just isn't that good. And I'd say it's like, well, you've already been courtside, backstage, and on pit row, and you've done all of these experiences because you get to do them in real life. But most people don't get to, and even if the experience is only half as good, if it's something that they never would have gotten to do before, it's still a very good thing. And as we can push that number up over time. It has a minimum viable value level when it does something that is valuable enough to people. As long as it's better inside the headset on any metric than it is outside, and people choose to go there, we're on the right path. And we have a value gradient that I'm just always hammering on. We can just follow this value gradient, just keep making things better, rather than going for that one close your eyes, swing for the fences, kind of silver bullet approach.
Well, I wonder if there's a value gradient for in-person meetings, because if you get that right, I mean, that would change the world.
Yeah.
It doesn't need to, I mean, you don't need Ready Player One. But I wonder if there's that value gradient to follow along. Because if there is, and you follow it, then there'll be a certain phase shift at a certain point where people will shift from Zoom to this. I wonder what are the bottlenecks? Is it software? Is it hardware? Is it all about latency?
So I have big arguments internally about strategic things like that, where like the next headset that's coming out that we've made various announcements about is going to be a higher intensity, more expensive, more features. Lots of people want to make those trade-offs. We'll see what the market has to say about the exact trade-offs we've made here. But if you want to replace Zoom, you need to have something that everybody has. And
so you like cheaper?
I like cheaper because also lighter and cheaper wind up being a virtuous cycle there, where expensive and more features tends to also lead towards heavier, and it just kind of goes, it's like, let's add more features. The features are not, they have physical presence and weight and draw from batteries and all of those things. So I've always favored a lower end, cheaper, faster approach. That's why I was always behind the mobile side of VR rather than the higher end PC headsets. I think that's proven out well. But there's, ideally we have a whole range of things, but if you've only got one or two things, it's important that those two things cover the scope that you think is most important. When we're in a world when it's like cell phones and there's 50 of them on the market covering every conceivable ecological niche you want, that's going to be great, but we're not going to be there for a while.
Where are the bottlenecks? Is it the hardware or the software?
Yeah, so right now, you can get workrooms on Quest, and you can set up these things, and it's pretty good experience. It's surprisingly good.
I haven't tried it.
Yeah.
It's surprisingly good.
The voice latency is better on that than a lot better than a Zoom meeting. So you've got a better sense of immediacy there. The expressions that you get from the current hardware with just kind of your controllers in your head is pretty realistic feeling. You've got a pretty good sense of being there with some of them.
Are these avatars of people?
Yeah.
Do you get to see their body?
Yeah.
And they're sitting around a table?
Yeah.
And it feels better than Zoom?
Better than you'd expect from that. It is definitely Yeah, I'd say it's quite a bit better than Zoom when everything's working right, but there's still all the rough edges of... The reason Zoom became so successful is because they just nailed the usability of everything. It's high quality with an absolutely first-rate experience, and we are not there yet with any of the VR stuff. I'm trying to push hard to get... I keep talking about it's like it needs to just be one click to make everything happen. And we're getting there in our home environment, not the whole Workrooms application, but the main home where you can now kind of go over and click an invite, and it still winds up taking 5 times longer than it should, but we're getting close to that where you click there, they click on their button, and then they're sitting there in this good presence with you. But latencies need to get a lot better. User interface needs to get a lot better. Ubiquity of the headsets needs to get better. We need to have 100 million of them out there just so that everybody knows somebody that uses this all the time.
Well, I think it's a virtuous cycle because I do think the interface is the thing that makes or breaks this kind of revolution. It's so interesting how like you said one click, but it's also like how you achieve that one click. I don't know what is can I ask a dark question? Maybe let's keep it outside of Meta, but this is about Meta, but also Google and big company. Are they able to do this kind of thing? It seems like, let me put on my cranky old man hat, is they seem to not do a good job of creating these user-friendly interfaces as they get bigger and bigger as a company. Like Google has created some of the greatest interfaces ever early on in its, creating Gmail. Just so many brilliant interfaces, and it just seems to be getting crappier and crappier at that. Same with Meta, same with Microsoft. It seems to get worse and worse at that. I don't know what it is. Because they've become more conservative, careful, risk averse. Is that why? Can you speak to that?
It's been really eye-opening to me working inside a tech titan, where I had my small companies, and then we were acquired by a mid-sized game publisher, and then Oculus getting acquired by Meta, and Meta has grown by a factor of many just in the 8 years since the acquisition. So I did not have experience with this, and it was interesting because I remember previously my benchmark for kind of use of resources was some of the government programs I interacted with on the aerospace side. And I remember thinking there was an Air Force program. They spent $50 million and they didn't launch anything. They didn't even build anything. It was just kind of like they made a bunch of papers and had some parts in a warehouse and nothing came of it. It's like $50 million. And I've had to radically recalibrate my sense of how much money can be spent with
without a product at the end
resources. Where on the plus side, VR has turned out we've built pretty much exactly what we just passed the 10-year mark then from my my first demo of the Rift. And if I could have said what I wanted to have, it would have been a standalone inside-out tracked 4K resolution headset that could still plug into a PC for high-end rendering. And that's exactly what we've got on Quest 2 right now.
First of all, let's pause on that with me being cranky and everything. What Meta achieved with Oculus and so on is incredible. I mean, this is when I thought about the future of VR, this is what I imagined in terms of hardware, I would say. And maybe in terms of the experience as well, but it's still not there somehow.
On the one hand, we did kind of achieve it and win, and we've sold, we're a success right now. But the amount of resources that have gone into it winds up getting cluttered up in accounting, where Mark did announce that they spent $10 billion a year, on Reality Labs. Now, Reality Labs covers a lot. VR was not the large part of it. It also had Portal and Spark and the big AR research efforts. And it's been expanding out to include AI and other things there, where there's a lot going on there. But $10 billion was just a number that I had trouble processing. I feel sick to my stomach thinking about that much money being spent. But that's how they demonstrate commitment to this, where it's not more so than Google goes and cancels all of these projects, different things like that, while Meta is really sticking with the funding of VR, and AR is still further out with it. So there's something to be said for that. It's not just going to vanish, the work's going in. I just wish it could be, all those resources could be applied more effectively. Because I see all these cases, I point out these examples of how a third party that we're kind of competing with in various ways. There's a number of these examples, and they do work with a tenth of the people that we do internally. And a lot of it comes from, there's the small company can just go do it, while in a big company, you do have to worry about, is there some SDK internally that you should be using because another team's making it? You have to have your cross-functional group meetups for different things. You do have more concerns about privacy or diversity and equity and safety of different things, parental issues, and things that a small startup company can just kind of, cowboy off and do something interesting. And there's a lot more that is a problem that you have to pay attention to in the big companies, but I'm not willing to believe that we are within even a factor of 2 or 4 of what the efficiency could be. You know, I am constantly kind of crying out for, we can do better than this.
Yeah, and you wonder what the mechanisms to unlock that efficiency are. You know, I don't, there is some sense in a large company that like an individual engineer might not believe that they can change the world. Maybe you delegate a little bit of the responsibility to be the one who changes the world in a big company, I think. But the reality is, like, the world will get changed by a single engineer anyway. So whether inside Google or inside a startup, it doesn't matter. It's just that Google and Meta needs to help those engineers believe. They're the ones that are going to decrease that latency. It'll take one John Carmack, like the 20-year-old Carmack that's inside Meta right now, to change everything.
I try to point that out and push people, like, try to go ahead and when you see something, because you get the silo mentality where you're like, okay, I know something's not right over there, but I'm staying in my lane here. And there's a couple people that I can think about that are willing to just like hop all over the place. And man, I treasure them. The people that are just willing to, they're fearless. You know, they will go over and they will go rebuild the kernel and change this distribution and go in and hack a firmware over here to get something done right. And that is relatively rare. You know, there's thousands of developers and you've got a small handful that are willing to operate at that level. And, you know, and it's potentially risky for them. The politics are real in a lot of that. And I'm in the very much the privileged position of, I'm more or less untouchable there, where I've been dinged like twice for it's like you said something insensitive in that post, and you should probably not say that. But for the most part, yes, I get away with every week I'm posting something pretty loud and opinionated internally, and I think that's useful for the company. But yeah, it's rare to have a position like that, and I can't necessarily offer advice for how someone can do that.
Well, you could offer advice to a company in general to give a little bit of freedom for the young, wild. Like, the wildest ideas come from the young minds, and so you need to give the young minds freedom to think big, wild, crazy. But that they have to be opinionated. They have to think crazy ideas and thoughts and pursue them with a full passion without being slowed down by bureaucracy or management. Obviously, startups really empower that, but big companies do too. And that's a design challenge for companies, for big companies, to see how can you enable that, how can you empower that.
Big companies, there are so many resources there, right. And they do amazing things do get accomplished, but there's so much more that could come out of that. And I'm always hopeful. I'm an optimist in almost everything. I think things can get better. I think that they can improve things. That you go through a path and you're learning kind of what does and doesn't work. And I'm not ready to be fatalistic about the kind of the outcome of any of that.
Me neither. I know too many good people inside of those large companies that are incredible. You have a friendship with Elon Musk. Often when I talk to him, he'll bring up how incredible of an engineer and just a big picture thinker you are. Is a huge amount of respect for you. I've never been a fly in the wall between the discussion between the two of you. I just wonder, is there something you guys debate, argue about, discuss? Is there some interesting problems that the two of you think about? You come from different worlds. Maybe there's some intersection in aerospace. Maybe there's some intersection in your new efforts in artificial intelligence. In terms of thinking, is there something interesting you could say about sort of the debates the two of you have?
So I think in some ways we do have a kind of similar background where we're almost exactly the same age, and we had kind of similar programming backgrounds on the personal computers, and even some of the books that we would read and things that would kind of turn us into the people that we are today. And I think there is a degree of sensibility similarities where we kind of call bullshit on the same things and kind of see the same opportunities in different technology. And there's that sense of, I always talk about the speed of light solutions for things, and he's thinking about kind of minimum manufacturing and engineering and operational standpoints for things. And so, I first met Elon right at the start of the aerospace era, where I wasn't familiar with, I was still in my game dev bubble. I really wasn't familiar with all the startups that were going and being successful and what went on with PayPal and all these different companies. But I met him as I was starting to do Armadillo Aerospace, and he came down with his right-hand propulsion guy and talked about, what can we do with it? It was kind of specific things about how are our flight computers set up, what are different propellant options, what can happen with different ways of putting things together. And then in some ways, he was certainly the biggest player in the sort of alt space community that was going on in the early 2000s. He was the most well-funded, although, his funding in the larger scheme of things compared to a NASA or something like that was really tiny. It was a lot more than I had at the time. But it was interesting. I had a point years later when I realized, okay, my financial resources at this point are basically what Elon's was when he went all in on SpaceX and Tesla. And I think in many corners he does not get the respect that he should about being a wealthy person that could just retire. And he went all in, where he was really going to, he could have gone bust. And there's plenty of people, you look at the sad athletes or entertainers that had all the money in the world and blew it. He could have been the business case example of that. But, the things that he was doing, space exploration, electrification of transportation, solar city type things, these are big world-level things. And I have a great deal of admiration that he was willing to throw himself so completely into that, because in contrast with myself, I was doing Armadillo Aerospace with this tightly bounded, it was John's crazy money at the time that had a finite limit on it. It was never going to impact me or my family if it completely failed. And I was still hedging my bets, working at id Software at the time when he had been, really all in there. And I have a huge amount of respect for that. And people do not, the other thing I get irritated with is people that say, like, oh, Elon's just a business guy. He just got, he was gifted the money and he's just kind of investing in all of this, when he was really deeply involved in a lot of the decisions. Not all of them were perfect, but he cared very much about engine material selection, propellant selection, and for years he'd be kind of telling me, it's like, get off that hydrogen peroxide stuff. It's like, liquid oxygen is the only proper oxidizer for this. And and like the times that I've gone through the factories with him, we're talking very detailed things about like how this weld is made, how this subassembly goes together, what are startup shutdown behaviors of the different things. So he is really in there at a very detailed level, and I think that he is the best modern example now of someone that can effectively micromanage some decisions on things on both Tesla and SpaceX to some degree, where he cares enough about it. I worry a lot that he's stretched too thin, that you get Boring Company and Neuralink and Twitter, all the other possible things there, where I know I've got limits on how much I can pay attention to, that I have to kind of box off different amounts of time. And I look back at my aerospace side of things, it's like I did not go all in on that. I did not commit myself at a level that it would have taken to be successful there. And and it's kind of a weird thing, just having a discussion with the richest man in the world right now. Right. He operates on on a level that is still very much in my wheelhouse on a technical side of things. So
doing that systems level type of thinking, where you can go to the low level details and go up high to the big picture. Do you think in the aerospace arena in the next 5-10 years, do you think we're going to put a human on Mars? Like, what do you think is the interesting?
No, I do. In fact, I made a bet with someone, with a group of people, kind of about whether boots on Mars by 2030. And this was kind of a fun story, because I was at an Intel-sponsored event, and we had a bunch of just world-class, brilliant people, and we were talking about computing stuff, but the after-dinner conversation was, like, what are some other things, how they're going to go in the future? And one of the ones tossed up on the whiteboard was boots on Mars by 2030. And most of the people in the room thought, yes. I thought that, like, SpaceX is kicking ass, we've got other possible stuff, it seems likely that it's going to go that way. And I said, no, I think less than 50% chance that it's going to make it there. And people, were kind of, why pessimism or whatever, and I'm an optimist in almost everything, but for me to be the one kind of outlier saying, no, I don't think so, then I started saying some of the things, and I said, well, let's be concrete about it. Let's bet $10,000 that it's not going to happen. And this was really a startling thing to see, that again, a room full of brilliant people, but as soon as money came on the line and they were like, do I want to put $10,000? And I was not the richest person in the room. There were people much better off than I was. There's a spectrum, but as soon as they started thinking, it's like, oh, I could lose money by keeping my position right now. And all these engineers, they engaged their brain. They started thinking, it's like, okay, launch windows, launch delays, like how many times would it take to get this right? What historical precedents do we have? And then it mostly came down to, it's like, well, what about in transit by 2030? And then what about different things, or would you go for 2032? But one of the people did go ahead and was optimistic enough to make a bet with me. So I have a $10,000 bet that by 2030. I think it's going to happen shortly thereafter. I think there will probably be infrastructure on Mars by 2030, but I don't think that we'll have humans on Mars on 2030. I think it's possible, but I think it's less than a 50% chance, so I felt safe making that bet.
Well, I think you had an interesting point. Correct me if I'm wrong. That's a dark one. That should perhaps help people appreciate Elon Musk, which is, in this particular effort, Elon is critical to the success. SpaceX seems to be critical to the humans on Mars by 2030 or thereabouts. So if something happens to Elon, then all of this collapses.
And this is in contrast to the other $10,000 bet I made kind of recently, and that was self-driving cars at like a level 5 running around cities. And people have kind of nitpicked that we probably don't mean exactly level 5, but the guy I'm having the bet with we know what we mean about this.
Jeff Atwood.
Yeah, coding horror and Stack Overflow and all. Yeah. But it's just, he doesn't think that people are going to be riding around in robo-taxis in 2030 in major cities, just like you take an Uber now. And I think it will.
You think it will?
And the difference is everybody looks at this, but Tesla's been wrong for years. They've been promising it for years, and it's not here yet. And the reason this is different than the bet with Mars is Mars really is more than is comfortable a bet on Elon Musk. That is his thing, and he is really going to leave heaven and earth to try to make that happen.
Perhaps not even SpaceX.
Yeah.
Perhaps just Elon Musk.
Yeah, because if Elon went away and SpaceX went public and got a board of directors, there are more profitable things they could be doing than focusing on human presence on Mars. It really is a sort of personal thing there. And in contrast with that, self-driving cars have a dozen credible companies working really hard. And while, yes, it's going slower than most people thought it would, betting against that is a bet against almost the entire world in terms of all of these companies that have all of these incentives. It's not just, one guy's passion project. And I do think that it is solvable, although I recognize it's not a 100% chance because it's possible the long tail of self-driving problems winds up being an AGI complete problem. I think there's plenty of value to mine out of it with narrow AI, and I think that it's going to happen probably more so than people expect. But it's that whole sigmoid curve where you overestimate the near-term progress, you underestimate the long-term progress. And I think self-driving is going to be like that, and I think 2030 is still a pretty good bet.
Yeah, unfortunately, self-driving is a problem that is safety critical, meaning that if you don't do it well, people get hurt.
But the other side of that is people are terrible drivers. So it is not going to be, that's probably going to be the argument that gets it through, is like we can save 10,000 lives a year by taking imperfect self-driving cars and letting them take over a lot of driving responsibilities. It's 30,000 people a year die in auto accidents right now in America, and a lot of those are preventable. And the problem is you'll have people that every time a Tesla crashes into something, you've got a bunch of people that literally have vested interest shorting Tesla to come out and make it the worst thing in the world. And people will be fighting against that, but optimist in me again, I think that we will have systems that are statistically safer than human drivers, and we will be saving thousands and thousands of lives every year when we can hand over more of those responsibilities to it.
I do still think, as a person who studied this problem very deeply from the human side as well, it's still an open problem how good/bad humans are at driving. It's a kind of funny thing we say about each other. Oh, humans suck at driving. Everybody except you, of course. Like, we think we're good at driving. But after really studying it, I think you start to notice, because I watched hundreds of hours of humans driving. We did projects and this kind of thing. You've noticed that even with the distraction, even with everything else, humans are able to do some incredible things with the attention, even when you're just looking at a smartphone, just to get cues from the environment, to make last seconds decisions, to use instinctual type of decisions that actually save your ass time and time and time again, and are able to do that with so much uncertainty around you in such a tricky dynamic environment. I don't know exactly how hard is it to beat that kind of skill of common sense reasoning.
So this is one of those interesting things that there's been a lot of studies about how experts in their field usually underestimate the progress that's going to happen, because an expert thinks about all the problems they deal with, and they're like, damn, I'm going to have a hard time solving all of this. And they filter out the fact that they are one expert in a field of thousands. And you think about, I can't do all of that, and you sometimes forget about the scope of the ecosystem that you're embedded in. And if you think back 8 years, very specifically, the state of AI and machine learning, where was that we had just gotten ResNets probably at that point, and you look at all the amazing magical things that could have happened in 8 years, and they do kind of seem to be happening a little faster in recent years also, and you project that 8 more years into the future, where, again, I think there's a 50% chance we're going to have signs of life of AGI, which we can put through driver's ed if we need to actually build self-driving cars. And I think that the narrow systems are going to have real value demonstrated well before that.
The signs of life in AGI, you've mentioned that. Okay, first of all, you're one of the most brilliant people on this earth. You could be solving a number of different problems, as you've mentioned. Your mind was attracted to nuclear energy. Obviously, virtual reality with the metaverse is something you could have a tremendous impact on.
So I do want to say a quick thing about nuclear energy, where this is something that this so precisely feels like aerospace before SpaceX, where from everything that I know about all of these, the physics of this stuff hasn't changed, and the reasons why things are expensive now are not fundamental. Somebody should be going into really hard Elon Musk style at fission, economical fission, not fusion, where the fusion is the kind of the darling of people that want to go and do nuclear because it doesn't have the taint that fission has in a lot of people's minds. But it's an almost absurdly complex thing where nuclear fusion is, you look at the tokamaks or any of the things that people are building, and it's doing all of this infrastructure just at the end of the day